Look closely at a drop of water floating in space. It doesn't hang, it doesn't stretch, it folds itself into a perfect sphere. No one shapes it. No hand holds it. It simply becomes round. In that silent motion, hidden in a fragment of liquid, lies a truth that spans the entire universe. Every atom, every star, every world, and even space-time itself all are drawn toward the same form. It's not beauty that guides them, nor intention. It's physics. Forces always seek the state with the least resistance, the lowest energy, the simplest equilibrium. And when nature rests, it rests in roundness. From bubbles drifting through air to the glowing skin of a planet, the same rule unfolds again and again. The round shape is nature's signature of peace, a sign that all the opposing forces have finally found balance. I've often wondered why the universe writes its poetry in circles, why perfection curves inward, not outward. Maybe it's because roundness isn't just a shape, it's the language of stability, a quiet promise that in a restless cosmos something still knows how to stay whole. If you could freeze the universe for just one moment, you would see it breathe in curves. Rivers bend, planets orbit, and galaxies swirl, never straight, never still. Behind those graceful arcs lies a rule so universal that nothing escapes it. Every curve is a compromise between energy and force, a silent negotiation written in the fabric of space. Even the smallest ripple on a pond is obeying that same cosmic agreement. The water moves not because it wants to, but because motion itself prefers a path that wastes the least energy. A curve instead of a corner, a loop instead of a line. Nature hates sharpness. Corners mean sudden change, and sudden change means stored tension. But when things bend, they relax. Energy flows smoothly. Stress dissolves, and the universe saves a fraction of effort. That efficiency is what makes everything from a soap bubble to a star surrender to the curve. Sometimes I imagine the universe as an artist who never lifts the brush. Every stroke it paints, every orbit it spins follows the same invisible command. Stay smooth, stay balanced, stay round. Every time a raindrop forms, an ancient rule of physics repeats itself. Tiny molecules of water pull on one another, creating an invisible skin. The skin tightens, squeezing the droplet into the smallest shape possible, a sphere. It's called surface tension, but it's really nature's way of saying, use less waste, less balance, more. On Earth, gravity stretches the droplet into a teardrop before it falls. But in space, freed from any pull, it perfects itself a flawless globe of liquid shimmering like glass. The shape doesn't come from beauty. It comes from pressure balance and the timeless drive towards simplicity. Surface tension exists everywhere molecules touch emptiness. It smooths edges, hides imperfections, and gives form to the smallest worlds. The same force that rounds a dewdrop also shapes bubbles in your morning coffee, and the stars that burn in distant space. When I watch that floating sphere of water, I can't help but feel a strange peace. It's the universe at rest, caught between motion and stillness, whispering its oldest truth. When energy finds harmony, everything becomes round. In every sphere, there's a secret geometry at work. It's the shape that packs the most volume into the least surface area, the most efficient form the universe can draw. Nothing else distributes pressure and energy so evenly. Every point on a sphere is equal distance from the center, each molecule sharing the same pull. It's a perfect democracy of forces. That balance isn't a coincidence. It's destiny written in equations. From the smallest atom to the largest star, matter rearranges itself to follow. Geometry's simplest rule: minimize effort, maximize harmony. When nature has no reason to be messy, it chooses the sphere. If you could peel apart that balance, you'd see equations whispering symmetry. It's the same math that makes bubbles float, stars burn evenly, and planets hold oceans steady. Every curve is a declaration of order, a quiet answer to chaos. Sometimes I think geometry is the universe's conscience, the reminder that even in vast disorder, something still remembers how to be fair, and that fairness, that balance, always finds its way back into a circle. A drop of water, a bubble of air, a glowing planet, three worlds, one law. Each of them is born from chaos and sculpted by balance. Inner bubble gas pushes outward while surface tension pulls inward until they meet in perfect truce. Inner planet gravity pulls everything toward the center while rotation tries to fling it apart. The result again is roundness, the quiet signature of peace between rival forces. It's astonishing how the same pattern repeats across such impossible scales. From millimeters to millions of kilometers, the same physics draws identical outlines. What changes is only what holds them together. Tension for bubbles, gravity for planets. In the silence of space, that balance becomes poetry. A planet is nothing more than a bubble of rock and gas inflated by time, sealed by gravity, floating in a cosmic ocean. Each one carries the memory of a droplet, simple, smooth, and eternal. Sometimes I wonder if the universe learned the idea of planet from something as small as a drop of rain. Because in the end, both are answers to the same question. How can energy rest? Everything we see, every curve, every contour is drawn by energy finding its balance. In physics, form is never random. It's the visible footprint of invisible forces settling into harmony. A cloud collapses into a star because gravity wins. A droplet rounds itself because surface tension minimizes strain. A planet forms because countless impact pressures and temperatures finally agree on one solution. The sphere, energy doesn't just move things, it sculpts them. Each wave, each pulse, each collision carves the path towards stability. And the endpoint of that journey is almost always round, because only the sphere lets energy rest without edges or corners to resist. You can think of the universe as a vast artist working with tension instead of paint. Every atom, every galaxy is one brushstroke in its endless pursuit of equilibrium. The shapes we see are just frozen moments in that choreography of forces. I sometimes imagine energy whispering to matter, "Stop struggling, be round, be still." And when it finally listens, the chaos softens, and the universe briefly remembers what peace looks like. If you could write perfection as an equation, it would be the geometry of a sphere. One simple formula, 4/3, times pi times the radius cubed describes its entire volume. Another 4 times pi times the radius squared defines its surface. Together they capture the universe's favorite compromise, the smallest boundary enclosing the greatest space. No shape uses less to hold more. Mathematically, the sphere is an endpoint, the solution nature always finds when all directions are equal, when no axis is special. From droplets to planets to stars, everything that stops fighting its own energy eventually solves the same equation. What's astonishing is how universal this math is. It doesn't care about scale, substance, or time. A carbon molecule and a neutron star both follow the same curvature of logic. Even black holes, the densest objects we know, obey the geometry of perfect roundness. To me it feels poetic that something as abstract as a formula could be the handwriting of creation. Each time we see a sphere, we're not just looking at a shape, we're looking at mathematics made real. Efficiency is the universe's hidden obsession. Every particle, every cloud, every orbit seeks to do more with less energy, less motion, less chaos. And no shape fulfills that demand better than the sphere. It stores mass, evenly spreads heat uniformly, and resists imbalance from every direction. In the grand economy of the cosmos, roundness is the ultimate savings plan. If you could watch a world forming from dust, you'd see that efficiency at work. Gravity pulls inward, pressure pushes outward, and together they bargain until the shape becomes effortless. Every bump, every irregularity, every mountain is slowly erased by time's patient hand, smoothing, balancing, perfecting. Even light obeys this logic. When it spreads from a source, it radiates in a sphere because that's the most efficient way to fill space evenly. The universe itself, expanding from its earliest fire, follows the same rule: energy shared in all directions, none favored. I think that's why roundness feels so natural to us. It's not just symmetry. It's economy made visible, a silent reminder that in a cosmos built on trade between forces, the sphere is the only fair deal. Imagine a single drop of water drifting through the darkness of orbit. No gravity, no wind, no container, only silence. It quivers for a moment, then pulls itself together, forming a floating pearl of liquid. Every molecule inside it feels the same tension, the same gentle tug toward the center. Without gravity, surface tension becomes its universe, sculpting a perfect sphere suspended in nothing. To the human eye, it looks delicate, almost alive. But what you're seeing is equilibrium in its purest form, every force matched, every imbalance erased. The drop has found the only shape that needs no correction. Astronauts have watched these spheres drift inside the space station, merging, dividing, glowing under soft light. They are tiny echoes of planets obeying the same physics on a smaller stage. Each droplet is a rehearsal for creation itself. Gravity's apprentice learning how to be a world. Sometimes I think that drop is the simplest version of the universe, alone round and perfectly still, yet holding within it the endless tension between motion and peace. In the beginning there is no order, just turbulence. Clouds of gas twist, collide and fragment in the void. Heat and motion tear through them, forming no pattern at all. Yet as time stretches, chaos begins to fade. Gravity gathers the scattered dust, pulling everything toward a center, and the storm begins to calm. From that violence, something astonishing happens. The shapeless becomes round. The gas collapses into a sphere not because it chooses to, but because that's the only form chaos allows to survive. In the tug-of-war between disorder and balance, roundness wins by endurance. It wastes nothing, loses nothing, breaks nothing. Every world, every star is born from that same surrender. What begins as an explosion ends as a sphere. The universe takes its own fury and folds it into symmetry, turning destruction into design. When I look at a planet hanging silent in the dark, I don't see perfection. I see peace carved out of chaos. A reminder that even the wildest storms eventually learn to curve. Every planet begins as rubble, loose rock ice and metal swirling around a newborn star. At first there is no shape, only motion. But slowly gravity begins its work. Piece by piece, collision by collision. The fragments fuse, heat rises, and the sphere takes form. Gravity doesn't care about design, it only knows how to pull. Yet through that simple pull, it sculpts the most elegant shape in existence. The young world melts from the energy of its own birth, softening into fluid stone. And in that molten state, gravity's hand grows steady, smoothing the jagged edges, rounding every mountain, pressing chaos into order. When the crust cools, the planet keeps that ancient memory, a shape born not from choice, but from inevitability. The same law that rounds a droplet has built an entire world. Sometimes I picture gravity as the universe's sculptor, blind but tireless, shaping not from vision but from persistence. It carves nothing by will, yet everything by patience. And when it's done, what remains is always the same, a perfect round silence. Every planet hides a silent struggle beneath its surface, the endless contest between gravity and solidity. Gravity pulls inward, demanding perfect roundness, while the planet's crust resists stiff and unyielding. For small worlds like asteroids rock winds easily. Their weak gravity cannot bend stone. But as mass grows, gravity strengthens its grip, and even solid matter begins to behave like liquid under immense pressure. It's not about melting, it's about surrender. The planet's body flows over geological time, mountains sink, valleys rise, and the surface slowly relaxes toward balance. Gravity patient as eternity always wins. That's why only large worlds become nearly perfect spheres. Their gravity is strong enough to make stone behave like clay. What feels rigid to us is on a cosmic timescale soft as breath. Whenever I see images of Earth from space, the smooth blue marble, I remember that beneath that calm curve lies tension, struggle and surrender frozen in motion. Roundness isn't peace, it's victory earned over billions of years. 4.5 billion years ago, Earth was not a planet, just a violent cloud of molten rock, metal and vapor spinning around the newborn sun. Asteroids crashed into it, endlessly heating its body until even iron flowed like water. In that chaos, gravity found its chance. Every drop of molten matter pulled every other toward the center, and slowly the rough sphere began to take shape. There was no surface yet, no ocean, no air, only glowing magma, swirling storms, and lightning splitting a crimson sky. But beneath all that rage, a quiet order was forming the first perfect curve of our world. When Earth finally cooled enough for a crust to solidify, it kept the memory of that molten roundness. Every mountain since then has been a tiny rebellion, every ocean trench a reminder of gravity's patience. Sometimes I think the Earth's roundness isn't just a shape, but a scar, a mark left by fire and collapse. What we now call home was once a glowing sphere of chaos, learning slowly how to be still. Roundness is not a coincidence, it's a milestone. The moment a forming world crosses a certain size, gravity takes command completely. Scientists call it hydrostatic equilibrium, the state where internal pressure and gravitational pull balance perfectly, shaping matter into a sphere. Before that point, asteroids remain jagged, broken, irregular. But once enough mass gathers, the rules change, rock flows, crust bends, and the planet becomes smooth. This transformation doesn't happen overnight. It takes millions of years of impact, heat, and motion for gravity to erase chaos. But once achieved, roundness becomes permanent. The planet has found its balance. Across the solar system, we can see this threshold drawn like a boundary between worlds. Ceres, the largest object in the asteroid belt, is just round enough to qualify. Smaller bodies fail the test, their shape still scarred by collisions. I like to think of that moment when chaos becomes geometry as the birth of belonging. When a world stops being debris and becomes something whole, the universe welcomes it with a perfect curve. Pick up a small asteroid, a mountain-sized boulder adrift in the void, and you'll see that gravity barely notices it. Its pull is too weak to bend solid stone. The rock can spin, tumble and crash, but its jagged edges remain. On worlds, this small solidity wins. Matter refuses to yield because the pressure inside is too low to overcome its own strength. That's why most asteroids look like fragments, not planets. They're shards of creation, frozen moments before gravity's rule begins. Only when enough mass gathers does that strength reverse, and rock begins to flow like soft wax over eons. There's something humbling about that threshold. A mountain on Earth would crumble under its own weight if scaled to planetary size, yet a mountain-sized rock in space can stand unchanged for billions of years. Scale decides everything, strength, shape, destiny. I sometimes imagine those tiny worlds as echoes of an unfinished thought, pieces that never grew heavy enough to remember how to be round. Every world must cross a quiet boundary before it earns its shape, a threshold where gravity becomes stronger than the material it holds. Scientists call this the yield point, the moment when stone stops resisting and begins to flow. Below that limit, matter stays rough and angular, but once a body grows large enough, its own weight crushes the high peaks, fills the low valleys, and sculpts a smooth, rounded form. For silicate rock, that threshold sits near 600 kilometers in diameter. For ice, far smaller, around 400. Beyond those numbers, nature bends the rules of rigidity and lets balance take over. This boundary divides the universe between what is broken and what is whole. Above it, gravity paints in circles. Below it, fragments remain forever unfinished. Each world in the cosmos carries its own story of how close it came to crossing that line. When I see a cratered asteroid tumbling through darkness, I don't just see a rock, I see a world that almost made it, a place that nearly remembered how to be round. Beyond the planets, the solar system is filled with half-finished worlds, moons too small, dwarfs too cold, asteroids too fractured to yield. Some like Mimas or Vesta, where the shape of near roundness but never quite crossed the line. Their gravity smooths the surface but not the core. Their strength resists complete surrender. They are the almost spheres of the cosmos frozen in compromise. Others like Pluto or Europa just barely make it. Their icy bodies, softer than rock, allow gravity to mold them into near-perfect globes. Each moon tells a story about its material and its mass, about how much it could bend before breaking. The result is a gallery of shapes between chaos and perfection. The potato-like forms of small moons, the stretched ellipsoids of dwarf planets, the cracked shells of icy bodies. They are snapshots of evolution halted mid-process. When I see them, I think of them not as failures, but as memories, reminders that roundness is earned, not given. Each irregular world shows us how close the universe came to balance, and how even imperfection follows a rule. Not every world reaches perfect symmetry, and that's what makes them beautiful. Each crater ridge and scar tells the story of a struggle that never truly ended. The moon with its pitted plains and jagged mountains isn't perfectly round yet. From afar it glows with quiet balance. It's the kind of beauty born not from flawlessness but from endurance. Nature rarely makes perfect shapes, it makes survivors. Perfection is just a direction, not a destination. Gravity tries forever to smooth the rough edges while impact and motion keep carving new ones. The result is a living geometry, one that breathes, changes and remembers. Even Earth carries that contradiction. It bulges slightly at the equator, its crust shifts, its oceans move, and yet we still call it round. Because roundness isn't absolute, it's a feeling of balance, the sense that forces have found their rhythm. Maybe that's why we find imperfect worlds so captivating. They remind us that harmony doesn't mean stillness, and that beauty in the cosmos is never static, it's always becoming. From the distance of space, every planet seems flawless. Smooth glowing, perfectly round, a celestial pearl against the black. But that's an illusion of scale. What looks like perfection from 1,000,000 kilometers away is rough and uneven up close. Earth's crust rises 10 kilometers above the sea and dips 11 below it. Yet compared to its size, that difference is barely a wrinkle, less than 1 part in 1,000. Roundness, it turns out, is a matter of perspective. When you step far enough back, chaos disappears and only balance remains. The same is true for the stars. Their surfaces boil and surge, mountains of plasma rising and collapsing, but across light years they shine as perfect orbs. Distance smooths everything. The farther we look, the more the universe seems ideal. I often think about that when I see Earth from orbit. Our mountains, our storms, our scars, they all dissolve into one quiet curve. Maybe the universe isn't perfect at all. Maybe it just looks that way when you're finally far enough to forgive it. There's a reason the human eye finds circles comforting. From the moment we're born, we're surrounded by them. The sun, the moon, the pupils that reflect our own image. Somewhere deep in our biology, roundness means safety. It signals completeness, continuity, the absence of sharpness or threat. Even in ancient art, the circle became the symbol of eternity because the eye never finds where it begins or ends. Maybe it's because we are creatures built inside a spherical world. Our horizon curves gently away, our sky forms a dome above us, and our planet itself holds us within its perfect arc. Our brains seem to recognize that symmetry. We trust circles, we revere spheres from architecture to atoms. They feel inevitable, as if the mind instinctively knows the laws that shape the cosmos. When I see Earth suspended in darkness, it feels almost personal, as if the universe designed the shape our eyes were born to love. The sphere isn't just geometry, it's home. Roundness isn't only written in planets or stars, it hides in the smallest things. Inside every atom, electrons don't trace sharp paths. They form clouds of probability that swell into spheres around their nuclei. That symmetry keeps matter stable, spreading energy evenly in all directions. The same principle that shapes galaxies also governs the space between protons. From the atom to the apple, the laws of geometry never change, only the scale does. If you could shrink yourself down to that invisible world, you'd see what gravity does in the macro, quantum forces do in the micro. They pull everything toward balance, wrapping energy in invisible circles. When you hold an apple, you're holding billions of atomic spheres bound into one larger sphere, a fractal of roundness repeating through scale. Even the droplets of dew that cling to its surface follow the same physics as planets forming in orbit. Sometimes I wonder if the universe simply loves continuity. Every level of matter echoes the one above it as if the cosmos were whispering the same word again and again round. When motion stops, shape begins to speak. Every object in the universe, once its forces balance, slips quietly into geometry, and almost always that geometry is round. A planet finds rest when gravity and pressure agree. A droplet rests when tension and cohesion match. Even a star burning at its core maintains its curve because its energy is perfectly balanced against collapse. Rest in the language of physics means symmetry. That's why the sphere is more than a shape. It's the final sentence of every physical argument. When all struggles are resolved, when every push meets its pull, the solution the universe writes is round. Stillness is rare in the cosmos. Everything moves, spins, and collides. Yet within that chaos, equilibrium emerges like a heartbeat of order. Every curve we see is a momentary pause in motion, a glimpse of balance before change begins again. Sometimes I think geometry is how the universe remembers its calm. A sphere isn't just a body at rest, it's motion that learned how to end gracefully. Equilibrium is the quiet architect behind every curve in the cosmos. It's not a force but a truce, a point where every influence agrees to stop fighting. In that balance, nature reveals its preferred design. The sphere, inside a star pressure from fusion pushes outward, while gravity presses inward with equal strength. Between those two infinities lies perfect stillness, not absence of motion, but harmony of forces carved into a round form. Every shape in the universe is a negotiation between energy and structure. Only the sphere ends that conversation without compromise. Even in tiny systems, a soap bubble, a droplet, a single cell, the same geometry appears. Wherever matter meets resistance, equilibrium finds the most efficient path to rest. The sphere wins because it wastes nothing. When I think of equilibrium, I imagine two hands pressing together with equal strength, unmoving, yet alive with tension. That invisible push and pull defines everything. We see a balance so perfect that it becomes shape. If you step back and simply look, you'll notice that nature never builds with straight lines. From seashells to sand dunes, from rippling clouds to the arcs of rivers, everything bends. The curve is the language of flow of forces finding the path of least resistance. Sharp angles cost energy, but curves let motion breathe. Even trees as they grow follow invisible arcs that distribute weight and tension evenly each branch, an echo of gravity's gentle persuasion. Nature prefers what works, not what's perfect. And what works best in a world of motion is the curve. The same rule appears in the living and the non-living alike. Cells round themselves to share nutrients, eggs take shape to endure pressure, and raindrops merge in circles because nothing simpler can survive. There's elegance in that repetition, a logic written across every form we know. When I see the spiral of a galaxy and the curl of a fern leaf, I can't help but think they're speaking the same dialect. The universe has only one handwriting, and it always signs its work with a curve. Life didn't invent the circle, it inherited it. Long before the first cells formed, the universe had already decided that roundness meant stability. When membranes closed upon themselves, they followed the same rule as droplets and planets. Minimize the surface, protect the core. Every living cell on Earth is a tiny echo of that law. A liquid world enclosed by a spherical wall. The geometry of life is the geometry of energy finding safety. Even at the molecular level, proteins fold into spirals and loops, never into hard corners. Life thrives in shapes that flow. You can see it everywhere in eyes, seeds, eggs, and even the pattern of a heartbeat. Each repeats the same rhythm the universe has practiced since time began. Contraction, expansion, balance. Physics didn't just shape matter, it shaped the rules that made biology possible. When I think of it that way, life feels less like an accident and more like a continuation. Every breath, every cell, every heartbeat is nature remembering how to be round. If you could zoom deep into life's architecture, you'd find that nature writes in circles. DNA coils into spirals that wrap around themselves, folding into loops to store the story of every living thing. Even viruses, the simplest messengers of biology, build themselves as spheres. each one a tiny fortress of symmetry. Roundness in life isn't decoration. Its efficiency a perfect way to protect information and share it with the world. When the laws of physics met the chemistry of life, they didn't argue, they agreed. The result was the geometry of existence. Curves, shells, and spirals repeating across every species. The pollen that floats through the air, the seeds drifting across oceans, even the bubbles in your blood all carry the same ancient code. They spread evenly, move smoothly, and endure because the sphere makes survival simple. Sometimes I wonder if evolution ever had a choice. It seems the moment life appeared, it simply followed a script. The universe had already written a script that always begins with a curve. Every circle we draw is a fragment of something greater. Cut through a sphere and you find its essence a perfect curve, endless and complete in 2 dimensions. From the halo around the moon to the rings rippling through water circles are the visible cross-sections of 3-dimensional harmony. They are how the universe lets us glimpse its geometry and pieces. We live surrounded by these slices of perfection. Orbits traced across the sky shadows cast during eclipses the round cross-section of a tree. Each one is a reminder that roundness is not flat. It's depth seen from a single angle. In mathematics, circles and spheres share the same soul symmetry that repeats no matter how you turn it. One is motion frozen in a plane, the other motion expanded into space. When I look at a full moon rising glowing like a white coin against darkness, I can't help but think, we're not seeing a circle at all, but a slice through infinity, one thin glimpse of the universe's favourite shape. A line becomes a circle when it bends back upon itself. A circle becomes a sphere when it bends through space. That single act folding dimension into dimension is how the universe builds complexity from simplicity. Every curve, when given room to grow, naturally expands into the 3rd dimension. The result is not just a larger shape, but a more complete one. The transition from flat to full is nature's quiet leap toward perfection. You can see it in the way bubbles form from a thin film or how galaxies twist from planar disks into faint domes of stars. Flatness never lasts long in the cosmos, depth is its destiny. Even our perception follows that rule. We draw circles on paper, but we imagine them as globes. The mind seems to know that roundness isn't meant to stay 2-dimensional. It wants to exist in volume, to enclose, to hold. Sometimes I think that's the universe's secret ambition, to turn every outline into a body, every motion into a world. The circle dreams of becoming a sphere, and in time it always does. Shapes don't feel, but we do. And somehow the curve speaks to something deep inside us. When we see a circle, we sense calm. When we see a sphere, we sense completion. It's not logic, it's resonance. The mind reads symmetry as safety, perhaps, because every round form in nature, the womb, the planet, the sun, once meant shelter. Our emotions have geometry too, and they bend toward the same simplicity the universe prefers. We trust curves because they promise continuity. No beginning, no end, just motion folded into harmony. Artists knew this long before scientists could explain it. Temples, domes, and orbits all share the same silent logic. Roundness draws the eye inward where stillness lives. In every culture, circles mark sacred things, the mandala, the halo, the ring. Maybe emotion itself follows the same physics. When something feels right, we say it's well-rounded. Perhaps balance in our hearts mirrors balance in the stars. Every drop, every planet, every star, all of them are born from motion yet shaped by rest. The sphere isn't a symbol of stillness. It's proof that chaos can organize itself. Energy, when left long enough to find balance, turns into form. That's why the universe, despite all its violence, keeps sculpting peace into matter. Roundness is not decoration. It's the fossil of energy that has learned discipline. The moment energy stops fighting itself, it becomes geometry, and geometry in turn becomes beauty. From the smallest atom to the curve of the cosmos, the same equation unfolds. Movement creates tension. Tension seeks release, and release becomes shape. Every sphere in the sky is a quiet record of that process. When I look at a world suspended in darkness, I don't see a planet. I see motion that has found meaning. a circle drawn by the hands of energy now resting in perfect balance order, born from chaos harmony, born from time. In space, perfection is never still, it's sculpted by pressure. Every sphere, from a droplet to a star, exists because inward and outward, forces have reached a fragile agreement. Pressure is gravity's counterpart, the silent hand that resists collapse. Without it, worlds would crumble into singularities. With too much of it, they would explode. Between those extremes lies harmony, the exact point where energy folds itself into balance and balance becomes roundness. It's a delicate tension, not peace, but precision. The physics of perfection written in invisible air. Deep inside a star, this agreement becomes sacred. Fusion pushes outward. Gravity pulls inward, and both surrender just enough to coexist. The surface that results a perfect sphere of fire isn't random, it's inevitable. Pressure makes sure that chaos cannot win forever. Whenever I see the sun rise, I think of that symmetry at work. Beneath its light is a balance so fierce that it builds beauty from violence. That's how the universe creates perfection, not by calm, but by control. At the heart of every round object lies a simple equation. The universe is ruled for efficiency. It says that nature always seeks the configuration with the least possible energy. Mathematicians call it a minimum surface problem. For a given volume, which shape requires the smallest boundary to hold it? The answer, proven by centuries of thought and countless experiments, is always the sphere. It minimizes effort, strain and surface tension all at once. That's why the same geometry appears in soap bubbles, molten planets, and even the outlines of subatomic fields. Nature doesn't choose beauty, it chooses efficiency, and beauty follows. When energy has room to move, it reorganizes itself toward this minimum. Ripples fade, edges, smooth imbalances vanish. In the end, what remains is not chaos reduced, but chaos arranged. The sphere is the physical solution to a mathematical truth. You can't do better with less. It fascinates me that the universe, vast and wild, obeys a rule so quiet, one that could fit on a chalkboard, yet builds entire worlds. Nature avoids edges the way water avoids walls. Every sharp boundary means a sudden change in energy, a place where stress builds and balance breaks. That's why the universe smooths everything it touches. Mountains crumble, droplets merge, even light bends. In the long timeline of physics, corners are only temporary, the cosmos always finds a way to curve them. A sphere is the final form of that smoothing process, the shape with no edges, no tension, no wasted force. To live in a universe like ours is to live inside geometry's softest solution. Even the laws of motion prefer continuity. When a particle travels through space, it follows curved paths in gravity's presence, never turning abruptly. On the grandest scales, galaxies flow the same way, curling into arms instead of snapping into lines. It's as if the universe itself can't stand sharpness. When I look at a smooth planet suspended in darkness, I realize how much effort went into erasing its edges. Billions of years of gravity's patient sculpting to make chaos seamless. In nature, a sharp corner is a cry of imbalance. It's where pressure gathers, heat concentrates, and energy strains to escape. Engineers learned this long ago. Even metal breaks faster where it bends too abruptly. The universe seems to know the same rule instinctively. Nothing that lasts stays angular for long. Water rounds the rocks, wind softens the cliffs, and time itself sands down every edge until smoothness wins. In the language of physics, a corner is a point of stress, and stress always seeks release. That release writes the curve. Even at cosmic scales, the same lesson holds. Galaxies twist into spirals, not triangles. Nebulae drift in clouds, not cubes. Gravity doesn't allow corners because corners trap imbalance, and imbalance cannot endure. Sometimes I think the roundness of the universe is its way of forgiving sharpness, of teaching everything. That tension left long enough always softens into grace. If gravity shapes the large surface, tension rules the small. It's the invisible force at every liquid skin, molecules pulling inward, trying to minimize exposure to shrink their world into the tiniest possible shape. That tension is why raindrops round themselves, why soap bubbles float like glass, and why a bead of dew clings to a leaf without falling. Surface tension is the small-scale echo of gravity doing the same job on a gentler stage. Every droplet is a tiny planet held together not by mass but by cohesion. A world in miniature obeying the same geometry as the stars. In the silence of microgravity, astronauts have watched water form perfect spheres trembling but unbroken. No container, no weight, just molecules bound by their shared desire to stay close. It's the simplest proof that nature doesn't need complexity to make art. When I see a bubble drift and shimmer in sunlight, I think of it as a universe contained in seconds, fragile, temporary, yet perfectly round while it lasts. A soap film looks fragile, but it hides a profound piece of mathematics. The shimmering surface stretching between two rings or across a bubble naturally adjusts itself to the smallest possible area. Mathematicians call this a minimal surface, and it obeys equations that balance curvature and tension perfectly. Every ripple in that film is a living diagram of energy-seeking rest. It bends, folds, and stabilizes until the shape becomes a solution not drawn by hand but solved by nature. When you blow a bubble, you're not just playing, you're watching mathematics perform itself in air. Researchers have even used soap films to model complex geometries from the shape of bridges to the surface of the cosmos. The film doesn't need computation. It already knows the answer. Molecule by molecule, it minimizes area, distributing tension evenly like a perfectly tuned fabric. Sometimes I think that if the universe could speak its language, it would sound like a soap film, fragile, shimmering, and always solving for balance. At the center of every world, two eternal rivals meet: gravity and pressure. Gravity pulls everything inward, tightening its grasp with every layer of mass. Pressure pushes outward, born from matter-resisting collapse. Their struggle defines a planet's size, density, and even its fate. In the molten cores of young worlds that conflict blazes like an argument without words, gravity demanding compression, pressure demanding space. The moment they reach balance, the chaos ends and the sphere is born. It's not peace they find, but equality. One hand pressing in the other, pushing out the shape between them is perfection. Every star, every gas giant, every molten planet is this balance made visible. Too little pressure and gravity wins, crushing everything into collapse. Too much, and the body shatters outward into emptiness. Between those extremes lies the narrow band where stability lives a thin margin, where the universe allows form to exist. When I think of that tension, I picture the sun itself, a roaring storm held steady by invisible agreement. Perfection, it seems, is always forged in opposition. Every star you see in the night sky, from the faintest red ember to the blinding blue giant, is simply a sphere of gas held together by its own gravity. There are no corners in starlight. Inside, hydrogen atoms collide with such fury that fusion begins releasing enough energy to push outward against collapse. The result is a perfect balance, a glowing equilibrium of pressure and pull. That's why stars are round. They are explosions contained by their own weight. Each one burns in silence, a bubble of fire obeying the same geometry as a droplet of water. From our distance, stars look eternal, but they are delicate negotiations. Too massive and they tear themselves apart. Too small and fusion never begins. Only within that narrow range can a sphere of plasma hold its shape, a golden balance between gravity's hunger and light's defiance. Sometimes I think of stars as lessons written in heat, that even destruction can find symmetry, and that roundness, even when burning, still means peace. Inside, a star pressure doesn't sit still, it dances. Every second, billions of tons of gas surge outward while gravity drags them back toward the core. This pulse is invisible to the eye, but written in light. The star trembles, contracts, and expands in slow rhythm like breathing made of fire. It's this oscillation, this quiet choreography between force and resistance that keeps the sphere alive. Too much expansion and the balance breaks. Too much collapse and the light goes out. The sphere endures only because these two movements never stop arguing. Some stars even sing their own pressure vibrating through space in waves of sound that astronomers can measure. Those vibrations reveal the heartbeat of the cosmos, gravity and heat speaking in rhythm. Each pulse is a reminder that perfection isn't stillness but motion sustained in balance. When I watch the sun, I imagine that endless dance beneath its calm glow. Pressure and gravity bow to each other step by step, forming the oldest waltz in the universe. Stars spin some slowly, some with terrifying speed, yet they almost never lose their perfect shape. Even as they whirl, their roundness endures. The reason lies in gravity's dominance. The force that holds a star together is so immense that rotation can barely distort it. The surface bulges slightly at the equator, but the overall symmetry remains intact. To gravity, the spin of a star is little more than a ripple on the skin of infinity. Inside the gas flows and circulates but always returns to equilibrium, a restless perfection that refuses to break. Some young stars rotate hundreds of times faster than the sun, their equators flung outward by centrifugal force. Even then, gravity keeps them nearly round, pulling every stray atom back into place. The result is a balance between motion and containment, the same law that shapes planets, droplets and galaxies alike. When I think of that, I see the universe as a great sculptor working in motion, spinning its creations endlessly, yet never letting them fall apart. Deep inside, every star pressure moves like a pulse. Layers of plasma expand and contract in response to tiny changes in heat, creating waves that ripple through the entire body. Some of those waves reach the surface, making the star flicker ever so slightly. Astronomers call this stellar seismology, the study of vibrations that reveal a star's inner structure. Each tremor is a beat in a rhythm older than time, driven by the competition between gravity's pull and energy's push. A star doesn't breathe air, but it breathes balance. Each pulse keeps it round alive and steady. By studying those vibrations, scientists can map the hidden layers of a star, its density, temperature, even its age. The data reads like a song score, with each note marking a shift in pressure and light. Sometimes when I see a star twinkle, I imagine I'm watching that ancient heartbeat from across the galaxy. It's strange to think that every flicker of light in the sky is just that the rhythm of equilibrium echoing through space. If pressure perfects, gravity creates. It is the universe's sculptor, invisible, patient and absolute. Every world, every star, every galaxy owes its shape to that relentless pull toward the center. Gravity does not carve with blades or heat. It molds through persistence. Over eons, it gathers dust, gas and light, drawing them into unity. The result is not chaos, but form a sphere emerging from formlessness, balance written by attraction itself. In the silence of space, gravity is the only artist that never sleeps, shaping the raw energy of creation into order. You can see its fingerprints everywhere, the smooth curve of a planet, the luminous shell of a star, the gentle arc of a galaxy's arms. Each is gravity's sculpture frozen mid-motion. Even the orbit of a moon is just a line drawn by its invisible hand. I often think of gravity as the universe remembering itself. Every object yearning to fall home, every curve a signature of belonging. Gravity has one rule: it pulls equally in every direction. From that symmetry, the sphere is born. No side, no corner, no edge receives more force than another. Each particle feels the same inward call, a perfect uniformity that can only resolve into roundness. That's why planets form as spheres, why stars burn in globes, and why even the invisible field around them expands in circles. The geometry of gravity is fairness itself. What it gives to one direction, it gives to all. It's not just a law of attraction, it's a law of equality written into space itself. Newton described it centuries ago when he realized that every piece of matter tugs on every other with the same strength across distance. A sphere then isn't just an accident, it's the natural shape of impartial force. When I look up at a planet glowing softly in the dark, I see gravity's democracy at work. No favoritism, no direction, chosen only the quiet assurance that the universe bends equally for all. Gravity isn't a single pull, it's a chorus. Every atom in the universe sings the same note of attraction, and together they create a field that stretches everywhere. Unlike magnetism, which has poles, gravity has no direction, no north or south, only inward. Every point in space feels it from all sides at once. That's why its geometry is spherical. It flows equally through every angle, shaping fields, orbits, and worlds into curves. This uniformity is what makes gravity so universal. It doesn't choose, it simply sums all the longing in matter and folds it toward the center. Einstein later showed that gravity isn't even a force, but the bending of space itself. Mass tells space how to curve, and space tells mass how to move. The result: every object falls along the same invisible arcs drawn toward the deepest point of curvature. When I think of that, it feels poetic that all the stars and planets we see are just space remembering how to bow evenly in every direction. At the heart of every stable world lies an invisible equation: hydrostatic equilibrium. It's the balance point where gravity's inward pull is exactly matched by pressure pushing outward. Inside a planet, molten rock flows until this symmetry is achieved. Inside a star, it's the outward heat of fusion that resists collapse. Without this balance, nothing round could exist. Too much gravity and the body crushes inward. Too little pressure and it crumbles apart. The sphere is simply the shape of that compromise, the geometry of agreement between weight and resistance. Every round world is proof that nature found its perfect middle. Even our sun, vast and violent, obeys this calm arithmetic. Its fiery layers hold position because every bit of falling mass is met by rising force. That's hydrostatic equilibrium in motion, the constant conversation that keeps a star alive. When I think of that quiet dialogue within the chaos of fusion, I realize the universe doesn't seek stillness, it seeks fairness. Roundness is the reward for balance kept. Every sphere in the cosmos lives on borrowed balance. When gravity grows stronger than pressure, the harmony that shaped it begins to fail. The surface folds inward, the core compresses, and roundness becomes collapse. Planets crack, stars shrink, and geometry gives way to gravity's hunger. What was once a perfect compromise turns into a spiral toward destruction. This is how stars die. Their fuel fading, pressure weakening, and their own weight reclaiming control. The round form remains for a moment trembling before the fall begins. The sun will one day face this fate, shedding its outer layers, leaving behind a dense white heart no larger than Earth. Even then, gravity won't stop. If the mass's greater collapse deepens, forcing atoms themselves to surrender, forming neutron stars, then black holes. In those depths, the shape of roundness becomes absolute space and time, curving into a perfect prison. Roundness, it seems, is not just the mark of balance, it is also the shape of the end. When a star like our sun exhausts its fuel, the fire at its heart fades. Without fusion's outward push, gravity begins to win, not violently but with slow, relentless certainty. The outer layers swell into a red giant, then drift away as glowing dust, leaving behind a brilliant ember. A white dwarf. It's the dense, silent core of what was once a living star, packed so tightly that a teaspoon of its matter would weigh as much as a mountain. Though it no longer burns, it shines with leftover heat. A ghost of the sun, still perfectly round, still ruled by equilibrium. Inside that tiny sphere, atomic pressure replaces fusions. Electrons crushed together form a quantum wall against collapse. It's called degeneracy pressure, the last defense against gravity's final demand. The star cannot shrink further nor expand again. It simply endures, cooling over trillions of years, fading from white to black. When I think of white dwarfs, I see them as monuments to endurance, tiny spheres of silence proving that even death in the cosmos keeps its symmetry. Some stars die more violently. When a massive one runs out of fuel, gravity doesn't stop at a white dwarf's calm. It surges inward, crushing atoms until even electrons and protons fuse into neutrons. The collapse is instant, a mountain's mass compressed into a single sugar cube of matter. What's left behind is a neutron star, a sphere only a few dozen kilometers wide yet heavier than the sun. Its surface curves space so tightly that light itself hesitates to escape. This is roundness taken to the extreme balance forged under impossible pressure. The crust of a neutron star is harder than diamond that spins so fast it can turn hundreds of times per second. Magnetic fields scream across its surface, carving invisible storms in space-time. Yet through all that chaos, its shape holds perfectly spherical, perfectly stable. Gravity has crushed imperfection out of existence. Sometimes I think the neutron star is the universe's cruelest masterpiece, a place where beauty and violence finally become indistinguishable. There is a point where even the laws of resistance fail, where no force left in nature can hold back gravity's collapse. When a massive star reaches that limit, it implodes completely. The core shrinks past atoms, past particles, past light itself, until all of its mass is contained within a single invisible boundary, the event horizon. Beyond that horizon, nothing returns. The sphere becomes absolute not of matter, but of space itself, curved so perfectly that geometry turns into destiny. The black hole is the universe's final sphere, the end of form and the perfection of gravity. It sounds like destruction, but in its way it's a kind of order. Gravity has finished its work so completely that even light obeys. What remains is not chaos, but silence, a curve so deep that time itself bows to it. The roundness here is no longer a shape we can see, but a boundary between existence and disappearance. Every black hole is a reminder that gravity's art has no mercy, and yet in its darkness the universe finds its most perfect symmetry. Inside a black hole, geometry breaks. Space once stretched and smooth folds inward until distance and direction lose meaning. Time itself bends, flowing toward the singularity the way rivers fall into the sea. Mathematically, the shape remains perfect, a sphere defined by the event horizon, but within it perfection becomes paradox. The deeper you fall, the more curvature devours reality. Every rule that kept the universe sensible begins to twist under gravity's command. It's as if the cosmos, in trying to draw the perfect circle, curved too far and fell into its own design. Einstein's equations describe this collapse flawlessly, yet they cannot escape it. Inside, the singularity mathematics reaches infinity, the point where description ends. We can only trace the edges where light orbits in endless loops trapped by the geometry it cannot leave. When I think about black holes, I don't see emptiness. I see geometry taken to its limit, roundness so pure it consumes the space that made it. Even in the black hole's dominion, light refuses to vanish quietly. Around the event horizon, photons spiral in endless orbits caught between escape and surrender. This thin region, called the photon sphere, glows like a halo made of trapped light. It's where the universe paints the outline of the unseeable. Every image we've ever captured of a black hole, every glowing ring of fire is this boundary light bending around darkness, revealing shape without revealing substance. In that glow, roundness becomes revelation. The shadow is circular because gravity bends light equally from every direction. Einstein predicted it, and a century later we saw it, the first photograph of a black hole framed by that golden ring. What we saw wasn't the hole itself, but the memory of light deflected by space so curved it circled back on itself. When I look at that image, I see the universe signing its name, a circle drawn by light to prove that even darkness must obey geometry. What we call a black hole's shadow isn't an object, it's a consequence. It's the outline left when light caught by gravity's pull bends around an invisible heart and never returns. The result is a perfect circle darker than anything the universe can make. Yet that darkness isn't emptiness, it's structure. It's where all directions point inward, where space folds so completely that infinity hides inside a boundary of finite size. The shadow is geometry made visible, a window not into light, but into how far space can curve before it breaks. It's the universe's most elegant absence. When astronomers captured the black hole in M87, what astonished them most wasn't the darkness, but its precision. The edge was smooth, symmetrical, almost flawless. Even in collapse, gravity had drawn a perfect circle. I sometimes wonder if that shadow is a mirror not showing us what's there, but how much of our own understanding still falls short. In chasing roundness to its limit, we discovered not perfection but infinity staring back. Even black holes rotate. When a dying star collapses, it keeps the spin it carried into life, only now that rotation is compressed into something infinitely small. The result is staggering. Some black holes turn hundreds of times per second, dragging the very fabric of space around them. This phenomenon, called frame dragging, means that inside their influence, even time itself begins to swirl. Matter, energy, and light are pulled into orbiting spirals, tracing perfect curves around something that has no surface at all. It's motion without edge speed, without sound, the universe's most extreme form of symmetry and motion. Rotation gives the black hole its structure and event horizon, slightly flattened by spin, a jet of light erupting from its poles, magnetic fields twisted into spirals. The faster it spins, the more the surrounding space is forced to dance. I find it haunting that even darkness refuses stillness. The black hole, the very symbol of collapse, cannot stop turning. Perhaps the universe itself is telling us something, that nothing, not even silence, exists without motion. From the poles of spinning black holes, light escapes where nothing else can. Twin jets of energy burst outward, stretching for thousands of light years. Beams of plasma so focused they outshine entire galaxies. These are not eruptions of chaos, but channels of order. Magnetic fields twist around the black hole's spin, funneling matter into narrow streams that pierce the void. In a universe where everything falls inward, these jets are the exception. Gravity's paradoxical gift of flight. They are the only places where destruction becomes creation, where collapse feeds the cosmos again. The matter hurled out by these jet seeds, new stars, new worlds, even new galaxies. Every atom that escapes will someday cool drift and gather again under gravity's call. The cycle continues, death shaping birth, roundness giving rise to motion. When I see the image of a jet slicing through darkness, I think of it as the universe exhaling, releasing what it cannot hold, yet still sculpting perfection from the debris. Nothing in the universe truly ends, it only transforms. The matter flung from dying stars and black hole jets drift through interstellar space, cooling into clouds of dust and gas. Over millions of years, gravity begins its patient work, again pulling the fragments inward, gathering chaos into curves. From these remnants, new stars ignite, new planets form, and new spheres rise from the ashes of the old. Roundness is reborn endlessly, not as repetition but as renewal, a constant rewriting of geometry across time. Every atom in your body has already passed through this cycle more than once. We are made of recycled symmetry, stardust, reshaped pressure, reheated gravity reborn in new forms. The same forces that round a droplet once sculpted the atoms in our bones. When we look at the sky, we are looking at our own origins replayed in light. Maybe that's the secret of the universe's design. It never stops learning how to be round. Creation, destruction, and rebirth are just three movements in one continuous curve. Every atom carries a history. The carbon in your lungs once burned inside a dying star. The iron in your blood was forged in a supernova's collapse. When those atoms drifted through the void and found each other again, they brought their memories with them. The record of heat, pressure, and motion that once shaped them. In that sense, matter never forgets. Every curve, every sphere we see is a memory replayed. The same physics, the same longing for balance repeated across new forms of existence. The universe does not rebuild from nothing. It remembers its own geometry. Even now, as stars explode and galaxies collide, the pattern holds. Matter scatters, reorganizes, and returns to roundness. It's as if the fabric of space itself has muscle memory, a habit of folding back into symmetry, no matter how far it's stretched. When I think about that, I realize we're not just made of stardust, we're made of repetition. We are matter remembering how to be whole again. Life too prefers the curve. From the shape of cells to the beating chambers of the heart, everything living bends. The round form minimizes stress, distributes energy, and protects what matters most. The fragile interior where motion becomes meaning. In every drop of blood, every seed, every eye, the sphere returns again and again as if biology itself inherited the geometry of the stars. The same physics that rounded planets now rounds the breadth of existence. We often think of life as defying nature, but in truth it is nature-perfected matter, learning to organize itself into living symmetry. Even at the level of evolution curves win, wing shells, fruits and eggs all adopt the same principle. The least resistance, the greatest strength, the gentlest form. Every living sphere is a compromise between vulnerability and survival. When I look at a single cell under a microscope, I see not just biology, but memory, the universe folding back on itself, creating another round world, small enough to fit on a glass slide. Of all the shapes life creates, none is more hauntingly familiar than the eye. A perfect sphere of fluid and light, it mirrors the stars themselves. Tiny worlds built for seeing other worlds. Inside transparent layers bend light into focus, forming miniature images of the universe beyond. The pupil expands and contracts like a cosmic aperture, balancing darkness and brightness with every blink. The eye is not just an organ, it is geometry evolved to witness geometry. In its curve lies both the design of perception and the reflection of the cosmos, one round form recognizing another. Across millions of species, nature repeats this pattern. Lenses, corneas, retinas, all shaped into circles to capture light evenly from every direction. The same law that rounds a droplet shapes the window through which we see it. Sometimes when I look up at the night sky, I imagine the universe staring back, countless eyes, biological and celestial, sharing the same geometry, all trying to understand themselves through the curve of light. Everything we see, every color, every shape arrives curved. Light doesn't travel in straight lines when space bends. It arcs around stars, diffuses through air, and refracts in the moisture of our eyes. Even our perception is sculpted by roundness. Each lens, each pupil, each retina, guiding photons along graceful paths toward meaning. The universe, in a sense, curves our understanding before we even begin to think. We don't just live in a rounded cosmos, we see through one. Every image we form, every horizon we trace is the product of curvature, translating light into memory. Our brains too are folded into curves, billions of neurons packed into soft spirals that amplify thought. Roundness helps them communicate faster, bridging distance through tight geometry. The mind itself is a sphere of connection mirroring the cosmos that shaped it. Sometimes I wonder if consciousness exists because of this, because matter learned to bend, to hold, to reflect. The same curve that gathers starlight may be the one that gathers awareness. If you could hold a thought in your hand, it might look like a ripple in water, expanding, folding, circling back. The human brain works the same way. Its surface isn't flat, but curved and coiled, each fold increasing the distance thoughts can travel, while keeping them close enough to connect. This geometry is no accident. It's efficiency shaped by evolution. Just as gravity sculpts a planet, biology sculpts the mind, seeking the most compact way to hold infinity. The brain's round form isn't just structure, it's function made visible. The universe folds and so do we. Our memories orbit one another like moons drawn by association, shaped by emotion. Even ideas form clusters circling a center: belief, curiosity, fear, wonder. Thought itself behaves like gravity binding fragments into constellations of meaning. When I imagine the mind, I don't see a machine of lines and logic. I see a small universe, spherical and self-aware, turning slowly in the light of its own understanding. We imagine time as a line past behind us, future ahead, but the universe tells a different story. In its grandest scales, time behaves like a curve. The expansion of space bends the path of moments, drawing beginnings and endings toward one another. In the equations of relativity, time and space form a single fabric warped by mass into smooth, continuous loops. That's why clocks slow near massive worlds, why gravity can bend not only light but duration itself. Time, it seems, is just another surface the universe has learned to round. From galaxies orbiting in spirals to particles oscillating in quantum rhythm, everything repeats patterns of return echoing through eternity. The cosmos doesn't flow forward, it circles, recycles, remembers. When I think of time that way, it no longer feels like something we move through, it feels like something we belong to, an endless orbit of causes and consequences where every moment curves back to touch the one before. At the edge of a black hole, time itself begins to fold. To an outside observer, anything falling toward the event horizon seems to slow its motion, stretching into eternity. But from within, time rushes forward, seconds collapse into nothing, as the fabric of space curves infinitely inward. This paradox reveals something profound. Time isn't constant, it's elastic. Under enough gravity, the universe can twist it, stretch it, even stop it. What we call forever might just be the moment when time gives up its shape. Roundness here becomes more than geometry, it becomes destiny. Einstein's equations predict that in such collapse, all paths lead to one point, the singularity where time and space exchange roles. The future becomes inward. The end becomes everywhere. To fall into that curve is to fall into inevitability, and yet even in that final descent the laws remain symmetrical. The universe does not break its own rules, it completes them. Time too follows the curve, ending exactly as it began, returning to the round. If you watch the universe long enough, nothing moves in straight lines. Stars are born in circular clouds, orbit in spirals, and die in expanding shells that round outward before fading. Galaxies collide, merge and settle into new rotating disks. Matter falls in, heats up, is thrown back out, cools and falls in again. Creation is not a single event, but a cycle, a loop written in orbits and rings. The cosmos does not simply begin and end. It circles like a clock whose hands are made of suns and worlds. Roundness is the shape that lets this loop continue, no edges to catch, no corners to break. Inside that cycle, atoms trade places endlessly. The calcium in your bones may once have drifted through the tail of a comet. The oxygen you breathe might have been trapped in the core of a giant star. Nothing is new, only rearranged, drawn again and again into spherical forms that live, shine and shatter. Sometimes I think the universe is not a line from birth to death, but a slow turning wheel. Every revolution reshapes the same matter into new circles, as if creation itself prefers to move in rounds. No shape in the universe exists by accident. Each one is the result of a negotiation, a conversation between forces that never stop speaking. Gravity pulls inward, energy pushes outward, rotation spreads, mass magnetism twists and pressure resists. Out of that argument form appears a sphere, an ellipse, a spiral, each is a treaty written in motion. Nothing is static, not even perfection. Every curve is a compromise that holds just long enough before the forces shift again. Roundness in this sense is not peace. It's balance held in tension, the silence between collisions. If you could watch the universe long enough, you'd see every shape breathing. Galaxies swell and thin planets stretch and settle. Even atoms vibrate with the constant push and pull of equilibrium. Shape is never fixed. Its performance a living dialogue between the laws of nature. When I think of it that way, the universe feels less like a sculpture and more like a song composed entirely of arguments that somehow stay in tune. For all its curves and symmetry, the universe is not flawless, and that is exactly why it works. Planets wobble on their axes, orbits stretch into ovals, stars flicker and flare. Galaxies are lopsided, warped by encounters with neighbours. Even the cosmic microwave background, the ancient afterglow of the Big Bang, is not perfectly smooth. Tiny ripples of temperature mark where matter was slightly denser, slightly thinner. Those flaws became galaxy stars and eventually us. If the cosmos had been perfectly uniform, nothing would have formed at all. Imperfection is not a mistake in the design, it is the design. Roundness shows us where forces have mostly settled, but the slight departures from that shape are where the story happens. Tides, seasons, climates, and evolution itself. Every bump on a planet, every asymmetry in a star is a record of events. Collisions, eruptions, encounters written into geometry. When I look at the sky, I don't see a flawless system. I see a universe that learned to use its own irregularities to build structure. The spheres are never exact, and that's the only reason anything interesting exists. Perfection may be the universe's ideal, but imperfection is what makes it alive. A planet slightly tilted gives us seasons. An orbit stretched just enough creates tides. Even the faint ripples in the early universe, tiny 1 part in 100,000, became the galaxies we see today. Without those small deviations, gravity would have had nothing to gather, and the universe would remain a smooth, featureless glow. Chaos in measured doses is how nature invents structure. It's not disorder that shapes the cosmos, but the uneven balance between order and chance. Every irregularity becomes a seed. A swirl in a gas cloud becomes a star, a fault in a planet's crust becomes a mountain range, a mutation in DNA becomes a new species. Creation hides inside a symmetry. The universe needs imperfections the way music needs dissonance, moments of tension that make resolution meaningful. When I look at the stars, I no longer see randomness as error. I see precision allowing variation, a perfect system that left room for surprise. The universe began in near-perfect symmetry, a sea of energy smooth in every direction, but perfect symmetry is sterile. When everything's the same, nothing happens. It was only when that symmetry broke, when matter slightly outnumbered antimatter, that creation began. Every particle, every atom, every star owes its existence to that tiny imbalance. Physicists call it symmetry breaking, but it's more than a term, it's the moment the universe chose difference over stillness. Roundness emerged not from perfection, but from the cracks where perfection failed. Even today, symmetry breaking rules the cosmos. Magnetic fields flip, molecules twist, galaxies spiral. Each event a reminder that order depends on contrast. Without difference, there is no structure, no meaning, no motion. The universe's beauty lies not in flawless repetition, but in how it handles disruption. When I think about that, it feels like a quiet truth whispered through physics itself, that harmony isn't the absence of difference, it's difference arranged well. Beneath every law of physics, symmetry hides like a blueprint. When nature treats all directions, all positions, all moments the same, something extraordinary happens: conservation. The symmetry of space gives us momentum. The symmetry of time gives us energy. The symmetry of charge gives us electromagnetism. These are not coincidences. They are the pillars that keep the cosmos from unraveling. Every force, every motion, every stable orbit is born from balance hidden in mathematics. The universe doesn't just have symmetry. It is symmetry folded into matter, motion, and light. But what's remarkable is how fragile that balance can be. Break one symmetry and a new law appears. From that broken order, the universe grows more complex, more structured, more alive. The roundness of planets, the spin of electrons, the shape of galaxies, all are echoes of symmetry bent but never lost. When I read the equations that describe it, I feel like I'm reading the universe's handwriting. Perfect patterns drawn with just enough imperfection to make everything possible. Symmetry gives the universe its order, but its failure gives it personality. When the perfect balance breaks, new forms of reality appear. The Higgs field, for example, arose from such a fracture, a cosmic shift that gave particles their mass. Without that imperfection, atoms could not exist, stars could not burn, and we would have no world to stand on. The universe depends on these moments of rebellion, where the old order cracks just enough to let something new take shape. Perfection, it turns out, can only describe what was. Creation begins where symmetry fails. You can see this principle everywhere. In crystals that shatter to form patterns in galaxies tilted and warped by collisions in ecosystems adapting after disturbance. Broken symmetry is how nature explores its own possibilities. It's not the end of balance, it's balance redefined. Sometimes I think of symmetry breaking as the universe, breathing, expanding, collapsing and shifting with each exhale. finding new ways to remain itself while changing forever. Even in its chaos, the universe speaks a steady language, a quiet grammar written in constants. The speed of light, the charge of an electron, the strength of gravity, these numbers never change. They hold the cosmos together like rhythm in a song, defining how stars burn, how atoms bind, how time itself unfolds. If any of them were slightly different, roundness might never exist. Worlds would not form, galaxies would not cohere. The universe's harmony depends on the precision of its constants, unchanging notes in a symphony of motion. Constants are the punctuation marks of creation, ensuring every sentence of physics makes sense. To scientists, these constants feel almost sacred values that emerge from nowhere yet govern everything. We don't know why they have the numbers they do. We only know that without them, the story collapses. Each constant is a promise that no matter how wild the universe becomes, some truths stay fixed. When I think about that, I feel a strange peace that beneath all the motion and imperfection, the universe still keeps time with itself, holding the beat steady so everything else can dance. Roundness might seem effortless, but in the universe it is anything but. Every sphere, from a droplet of rain to a neutron star, is maintained by countless equations in perfect agreement. Gravity, pressure, temperature, and motion must align within razor-thin margins. The Earth, for example, is almost a perfect sphere, yet its equatorial bulge measures just 21 kilometers of distortion, smaller than a single grain on a polished marble. That precision is astonishing, achieved not by design but by balance evolving over billions of years. Roundness isn't simplicity, it's accuracy made visible. When scientists model planets, they find that even minor shifts in rotation or density can ruin that symmetry. But nature corrects itself. Tide smooths surfaces, pressure redistributes, mass and motion evens out the roughness. The universe is relentless in its arithmetic, always recalculating, always refining. Sometimes I think the sphere is the cosmos's proof of consistency. The same rules working everywhere, producing the same perfection again and again down to the last decimal of curvature. A sphere at rest is flawless, but the universe never rests. Once it moves, perfection begins to flex. The faster a planet spins, the more its equator swells. The faster a star rotates, the flatter its poles become. Motion adds tension, a reminder that even the most balanced forms must bend to speed. Yet instead of breaking, roundness adapts. It becomes an oblate world, a living equation between gravity and motion, compression and expansion. The universe doesn't punish motion for disturbing symmetry, it refines it into a new kind of balance. Perfection, it seems, is never still, it's constantly negotiated in motion, from Earth's gentle bulge to Jupiter's dramatic flattening. Every spinning sphere tells the same story. Movement reshapes geometry without destroying it. The curve changes, but the idea remains. Even photons, massless and eternal, follow curved paths through spacetime's gravity wells. When I see a rotating planet, I don't see imperfection. I see motion carving beauty, the proof that the universe values balance not as stillness, but as adaptation. Speed distorts everything it touches. When an object nears the speed of light, its length contracts, its mass increases, and time itself slows down. Einstein showed that motion isn't just movement, it's transformation. To a traveller moving near light speed, the universe flattens ahead and stretches behind distances, curling into new geometry. Even roundness changes under this strain. A perfect sphere rushing through space no longer appears perfectly round. Its beauty shifts with the observer's frame of reference. The faster we move, the less the universe stays the same. Yet the laws shaping it never break, they simply bend with motion. In relativity, speed is not an escape from symmetry, but a new form of it. The equations stay identical for every observer no matter how fast they move. This is the hidden grace of the cosmos. Even when everything looks distorted, the underlying harmony holds. When I think about that, I realize speed doesn't destroy roundness. It teaches us that perfection is never absolute. It depends on where you stand and how fast you're moving through the curve of time. Einstein's greatest insight was that space itself is not a stage but a participant. Mass and energy bend it, turning straight lines into arcs and orbits. What we call gravity is simply the motion of objects following those curves. Every star, planet, and galaxy reshapes the fabric around it, a web of invisible roundness stretched through 4 dimensions. Space is elastic and its geometry changes with what it contains. The more massive the body, the deeper the curve. It's a quiet revolution in thinking. The universe doesn't live inside geometry. Geometry is the universe. Imagine rolling a marble across a stretched sheet. The marble curves not because of a force, but because the sheet itself is warped. That's space-time in action, a round law written into the structure of reality. Even light, which has no mass, obeys it perfectly, bending around stars as if bowing to their presence. When I think of that, it feels almost poetic that everything from the smallest photon to the largest cluster moves not in defiance of the universe's curves, but in devotion to them. If you could travel far enough in any direction, you might never find an edge, only a curve returning you to where you began. The universe on its largest scales behaves not like a flat sheet, but like an enormous bubble of space-time. Galaxies trace arcs around invisible geometry. Light bends and orbits twist through gravitational valleys. Straight lines exist only in theory. In reality, everything follows curvature, whether drawn by gravity, by motion, or by expansion itself. The cosmos has no corners, no true straightness, just endless bending, smooth and continuous like a thought that never ends. Even expansion curves. Space doesn't stretch outward into emptiness. It expands within itself, every point moving away from every other in perfect symmetry. The farther you go, the more circular the journey becomes. Sometimes I wonder if that's why we find straightness so unnatural, why rivers meander, planets orbit, and even our thoughts loop back on themselves. Perhaps the universe doesn't know how to move in lines. It only knows how to turn. For centuries, astronomers wondered, if everything bends, then what's the universe bending into? The answer is stranger than imagination allows. It bends into itself. Space doesn't need an outside. It curves internally like the surface of a sphere where every direction eventually leads back home. The universe may be flat on local scales, but when viewed as a whole, it could be finite yet unbounded, endless motion within a closed geometry. You can travel forever without crossing an edge because there are no edges to cross. The cosmos is not infinite distance. It is infinite continuity. Cosmic background radiation gives us clues, faint ripples perfectly aligned, suggesting a universe slightly curved but remarkably smooth. If you could see the entire structure, you might glimpse something like a vast 4-dimensional bubble expanding, cooling, evolving, yet still round at its core. When I think of that, it feels comforting. The universe doesn't stretch into nowhere. It folds into meaning, a single continuous curve carrying everything we know. If you could step outside the universe and look back, what would it look like? Not a grid of stars or a field of points, but a vast glowing sphere of space-time expanding from every direction at once. There would be no center, no up or down, just light stretching across the curvature of infinity. From the outside, it would appear timeless, a single round moment containing everything that ever was or will be. Inside, we call it history. From beyond it would simply be geometry. Perhaps the universe isn't unfolding through time. Perhaps it is time seen all at once. The laws of physics suggest such a view is possible in theory, even if we could never witness it. The entire cosmos, every photon, every atom, every thought frozen within one vast 4-dimensional sphere. It wouldn't be expanding anymore because all motion would already be contained. The Big Bang, the present and the distant future all existing as one. When I imagine that view, I realize we are inside a masterpiece. We can never fully see a universe perfectly round, even in the dimensions of time. From inside the universe, we can't see its shape, only its effects. Light reaches us along bent paths. Space stretches between galaxies, and the horizon of what we can observe drifts farther each day. To us, the universe feels flat and endless, but that's only because we're too small to feel the curve. It's like standing on Earth and insisting the planet has no roundness, because the ground looks straight beneath our feet. From our limited vantage, infinity and curvature feel the same. We're inside the sphere we're trying to measure, seeing only the arcs, never the whole. The cosmic microwave background, that ancient radiation still humming through space, is our best mirror. It shows the faintest clues of curvature, but not enough to define the full shape. For now we live in uncertainty, tracing shadows of geometry from within the structure itself. Sometimes I think that's fitting. The universe keeps its symmetry close, letting us explore it piece by piece, as if roundness in its deepest form was meant to be understood from the inside out. Every observer in the universe lives behind a horizon. For us it's called the cosmic horizon, the farthest distance light has reached since the Big Bang. Beyond it, space continues, but its light hasn't had time to arrive. It's not a wall, but a limit of knowledge. Each day, as the universe expands, new regions slip beyond reach, their light stretched into silence. What we can see is just a small glowing bubble surrounded by darkness, not because the cosmos ends, but because time does. Our understanding ends where light can no longer keep up. To me, that horizon feels less like a boundary and more like a mirror. It shows how knowledge itself behaves, expanding but always chasing light that moves just a little faster. Every discovery pushes the edge outward, revealing more of the same endless curve. Maybe that's the universe's quiet lesson, that no matter how much we learn, there will always be a horizon ahead, a perfect circle of unknowing, reminding us that mystery is built into the shape of reality. Every second the universe grows larger, not because light moves faster, but because space itself stretches. The galaxies at the edge of what we can see are racing away so quickly that their light takes billions of years to reach us, red-shifted into faint whispers of their past. The edge of visibility moves outward, but so does the darkness beyond it. This balanced light-chasing expansion defines what we can ever know. The cosmic horizon isn't fixed. It's alive, expanding with the universe itself. In that sense, the frontier of knowledge moves with us, forever receding, forever round. When we observe deep space, we're really looking into time, each photon, a messenger from an earlier epoch. Some left their galaxies before Earth even formed, yet as they arrive, new galaxies move beyond reach, their light destined never to find us. The horizon breathes, expanding outward like the surface of an inflating sphere, carrying time and light in every direction. When I think of that, I realize the universe isn't a story moving forward. It's a light wave still unfolding, and we're standing inside its glow. From our position in space, the universe appears as a perfect sphere. The observable universe centered on us, defined not by where we are, but by how far light has traveled. Every observer, no matter where they stand, sees the same. A round bubble of visibility, 13.8 billion light-years in every direction. It isn't that we're at the center of everything, it's that light defines its own horizon, and every conscious eye becomes the center of its own sphere of time. In that geometry, observation itself creates roundness. Every view of the cosmos is symmetrical from where it's seen. This idea is humbling. No matter who looks or where, the universe curves around them the same way. Each point in space holds its own horizon, its own circular map of existence. What connects us is not our position, but the shared shape of what we can see. When I think of that, I realize the roundness of the observable universe isn't just physical, it's personal. The cosmos gives everyone their own sphere of light centered on their place in time. It sounds impossible that everyone everywhere is at the center of the universe, but that's what relativity tells us. The cosmos has no single middle. It expands evenly in all directions, so every point becomes its own center of observation. From any galaxy, the view looks the same. Stars receding, light stretch the horizon round and complete. We are not privileged, only positioned. The center isn't a place. It's a perspective drawn by light's finite speed and time's endless reach. The universe doesn't favor us with symmetry. It gives it to everyone. That idea changes everything. It means that being at the center is not about where we are, but about how we see. Every observer stands inside their own bubble of history with light, arriving from all around a perfectly spherical story written in photons. Sometimes I find that comforting. In a universe without edges or hierarchy, every point, every consciousness shares the same geometry. We are all centers of our own expanding circle of light. Everywhere we look, symmetry echoes not just in space but in existence itself. For every star shining outward, there is darkness holding its light. For every galaxy drifting away, another moves in perfect opposition. Even the laws of physics hold their balance. Matter and antimatter, attraction and repulsion, motion and rest. It's as if the universe can't create one without creating its reflection. Existence in this way is never one-sided, it's a mirror turned in on itself, curving balance into being. The cosmos doesn't just allow symmetry, it depends on it to keep itself whole, but perfect balance never lasts. Matter outweighed antimatter by the smallest margin, and that fraction made everything possible: stars, planets, and life. Symmetry gives structure, asymmetry gives story. Together they weave the fabric of what is. Sometimes when I think about this cosmic balance, it feels deeply human, as if the laws that shape galaxies also shape meaning. Every loss and gain, every collapse and creation keeps existence round not flat, forever turning, forever whole. The universe writes in contrast. Light reveals structure, but shadow gives it depth. Without darkness, brightness has no meaning. Without emptiness, fullness cannot exist. Stars burn because space is black. Galaxies glow because the void allows their light to travel. Even our vision depends on shadow. The eye can only detect contrast, not absolutes. In that sense, the cosmos builds beauty the way an artist does, not by filling everything with light, but by leaving room for darkness to define the roundness of form. Every star owes its shape to the darkness that surrounds it. At cosmic scales, this balance is everywhere. Black holes and nebulae, day and night creation, and collapse pairs of opposites forming one whole. The same equilibrium that keeps planets in orbit also keeps galaxies from tearing apart. The universe never eliminates shadow, it uses it to sculpt light. When I look at the night sky, I don't see darkness as absence. I see it as the canvas, the quiet partner that lets the universe draw its perfect circles of flame. Darkness isn't empty, it has shape. Between galaxies, invisible matter forms vast filaments stretching across the universe, linking clusters in a cosmic web. These strands of dark matter don't shine, but they give structure to everything that does. Gravity flows along their paths, guiding the formation of galaxies like beads strung on invisible threads. Even where no light travels, form persists a geometry made of absent shaping presence. The roundness we see in stars and worlds begins here in the unseen architecture of shadow. Astronomers can't see dark matter directly, but they can map its influence, the way it bends light from distant galaxies, the way it anchors cosmic motion. It's the skeleton of the universe, silent yet essential, turning emptiness into structure. When I imagine it, I see a web of gravity pulsing through space round at every junction, curved by unseen hands. Darkness isn't the opposite of light, it's the frame that holds it. Beneath every shining galaxy lies an invisible foundation, the scaffolding of dark matter. It stretches across the universe like a cosmic skeleton, its filaments weaving through billions of light years. Where those filaments cross galaxies, form clustering into vast rounded nodes that mirror the geometry of their unseen supports. The visible universe, every star, nebula and planet, is just the surface texture of this greater structure. We live not in empty space, but within a web of invisible gravity. Roundness even here is no accident. It emerges wherever mass gathers along these unseen threads. Computer simulations reveal this hidden pattern, an endless network of curved bridges and spherical hubs. It's a geometry both chaotic and orderly, the product of gravity organizing the unseeable. Over time, this skeleton shaped everything we now observe, from the smallest galaxies to the great cosmic walls spanning the sky. When I imagine that structure, I see the universe not as a collection of isolated lights, but as one vast organism curved, connected, and held together by the invisible symmetry of its own design. If you could step far enough away to see it all, the universe would look like a glowing web stretched across infinity. Thin filaments of galaxies connect in vast arcs, forming nodes where superclusters gather. Between them lie enormous voids, hollows so immense that entire clusters could disappear inside. This is the cosmic web, the largest structure ever discovered, and yet it follows the same rule as a droplet or a planet. Balance! Matter flows along invisible curves drawn by gravity into a pattern that repeats itself from the smallest scale to the largest. It's the roundness of connection, a universe woven not built. Astronomers mapped this structure using light from distant quasars and the motion of galaxies. What emerged was breathtaking. A cosmic tapestry curved and living billions of light-years wide. Every strand hums with hidden matter. Every junction glows with the heat of creation. The web is not static. It stretches and shifts as the universe expands, but its overall symmetry endures. When I think of it, I no longer imagine space as empty. I see a living fabric, vast and delicate, where gravity itself weaves the threads of existence. Between the shining filaments of the cosmic web lies the true wilderness of the universe. Vast regions nearly empty of matter. These cosmic voids span hundreds of millions of light years where galaxies are scarce, and gravity's pull grows faint. At first glance they seem like holes blank and meaningless, but even emptiness has geometry. Voids expand as matter drains away, forming almost perfect spheres. Bubbles of low density pushing against one another like air pockets in a cosmic foam. Nothingness, it turns out, also prefers to be round. The universe curves even where there is nothing left to curve. These voids shape the web around them just as valleys define mountains. Their pressure drives matter into the filaments, amplifying contrast between full and empty. In this way, emptiness sculpts existence, the invisible hand behind the universe's pattern. When I think of these silent spheres of nothing, I find them strangely peaceful. Even the absence of matter follows the same law as everything else. Balance through curvature, harmony through space itself, learning how to breathe. From a great enough distance, the universe begins to look like something familiar: foam. Galaxies, clusters, and filaments trace thin walls surrounding vast spherical voids, just like bubbles packed together in a sea of light. Astronomers call it the cosmic foam, a structure so immense that each bubble could contain millions of galaxies. The same physics that shapes soap bubbles on water surface tension, minimizing energy, plays out across billions of light years, written in gravity and expansion instead of air and film. Roundness is the rule no matter the scale. From droplets to universes, energy always seeks the curve. Computer simulations reveal this cosmic foam growing and shifting bubbles, merging and stretching as the universe expands. Over time, the structure becomes more delicate: voids, empty, further filaments thin, and the geometry smooths into something almost serene. The universe, it seems, is evolving toward equilibrium, one vast slow exhalation of order. When I see that pattern, I realize we're floating inside a bubble too, a curved fragment in an infinite sea of cosmic foam, held together by gravity's patient hand. Across the ages, gravity has worked like a silent sculptor, patient, tireless, and exact. It doesn't carve with violence, but with time. Every orbit, every collision, every gentle pull between stars is a stroke of its invisible chisel. Galaxies twist under its guidance, clusters drift into balance, and entire cosmic walls take shape along its curves. The universe itself is a sculpture in motion, refined over billions of years. Even the smallest grains of dust follow gravity's design, circling into rings that will one day become worlds. Roundness is gravity's signature, the mark it leaves on everything it touches. But gravity never finishes its work. The structures it builds continue to evolve, stretching, collapsing, reshaping themselves under its pull. The sculpture is a live, changing form without ever losing its harmony. When I think about this, I see the universe not as a static masterpiece, but as a workshop gravity's eternal studio, where matter never stops moving toward beauty. Every motion in the universe follows designed. From the arc of a comet to the orbit of a star cluster, movement traces geometry as surely as a sculptor follows form. Nothing drifts aimlessly. Each path is drawn by invisible equations of gravity, inertia, and time. Together they create a structure not built from stone or light, but from rhythm, the harmony of motion. When matter moves, it doesn't simply travel. It builds shape. The roundness of a planet, the swirl of a spiral galaxy, even the oscillation of atoms, all are architecture written in motion. The universe doesn't just exist in space. It constructs space through movement. When physicists describe celestial mechanics, they speak in curves, ellipses, spirals, or parabolas, never straight lines. Each one is a signature of balance between energy and attraction. This is the cosmos's secret. Motion is structure. The paths themselves give rise to the forms we see. Sometimes I imagine gravity as an architect that never draws a line, only circles sketching reality again and again until motion itself becomes design. Nothing in the universe is born still. Motion comes first, form follows. As clouds of gas collapse under gravity, they begin to spin, flattening into disks and rings. Out of that rotation, stars ignite, planets gather, and orbits align. The shapes we see, spheres, spirals, ellipses, are the footprints of motion solidified. Even the smallest dust particle drifting through a nebula carries the memory of its path in its shape. Form in the end is just motion that has found equilibrium. Roundness is not created by stillness, but by movement perfectly resolved. Nothing in the universe is born still. Motion comes first, form follows. As clouds of gas collapse under gravity, they begin to spin, flattening into disks and rings. Out of that rotation, stars ignite, planets gather, and orbits align. The shapes we see, spheres, spirals, ellipses, are the footprints of motion solidified. Even the smallest dust particle drifting through a nebula carries the memory of its path in its shape. Form in the end is just motion that has found equilibrium. Roundness is not created by stillness, but by movement perfectly resolved. Everywhere in the cosmos, creation begins as a dance. Clouds of gas swirl, collide, and fall inward, spinning faster as they collapse. The motion tightens, chaos refines, and symmetry emerges. From turbulence comes rhythm, from rhythm form. Gravity leads the steps. Energy keeps the pace. And together they choreograph the birth of stars, planets, and worlds. This dance has no beginning or end, only variation. Each new structure is a movement in a performance that has lasted for 14 billion years. Creation at its heart is motion learning to move beautifully. You can see this dance in the rings of Saturn, the spirals of galaxies, the shimmering waves of plasma on the sun's surface. Even at the smallest scales, particles orbit one another in patterns that echo the heavens. Every orbit, every rotation, every revolution is a step in the same choreography, gravity's eternal waltz. When I look up at the stars, I no longer see stillness. I see motion held in perfect time, a cosmic dance that never ends, only changes partners. The universe moves to a rhythm older than stars. Every rotation, every orbit, every pulse of light follows timing written in gravity and energy. The moon circles Earth in 27 days. Earth turns around the sun in 365, and the sun drifts through the Milky Way over 200 million years. Each motion is a note in a grand composition, a harmony of scales spanning from atoms to galaxies. Time itself is the metronome keeping everything in step. We don't just live in the rhythm of the cosmos. We are part of its beat. Even the expansion of the universe hums with rhythm waves of energy, stretching across space-time, echoed in the cosmic microwave background. Pulses tick like celestial clocks, their signals precise enough to measure the drift of galaxies. From heartbeats to planetary revolutions, rhythm unites all forms of motion. Sometimes I think that's why silence feels uneasy, because the universe itself never stops moving, never stops keeping time. Even in stillness, everything continues to turn. If rhythm is the heartbeat of the cosmos, then motion is its music. Every orbit, every vibration, every wave sings a note in the grand symphony of existence. Planets hum in frequencies too deep for ears to hear. Stars vibrate in complex harmonics, their surfaces rippling with patterns that reveal their inner structure. Even black holes, once thought silent, ring when they collide. Gravitational waves echoing through space-time like chords struck on the strings of reality itself. The universe isn't quiet. It's just playing in keys our bodies weren't built to sense. Astronomers have translated these vibrations into sound, a chorus of tones from galaxies' pulsars and the deep background hum of the cosmos. Each is a signature unique yet connected, woven into the fabric of motion. To listen is to glimpse the hidden rhythm behind everything that moves. When I hear those sounds, faint, mathematical, ancient, I realize that motion itself is music. The universe doesn't just exist, it performs. Behind every motion lies harmony, the quiet agreement of forces that allows movement to endure. A planet doesn't fall into its star because gravity and velocity hold one another in conversation. A galaxy doesn't fly apart because the dark matter within it provides a counterweight. Even the expansion of the universe balances the pull of matter with the push of dark energy. It's a cosmic duet attraction and repulsion structure, an expansion, chaos, and order playing in perfect synchrony. Harmony in the end isn't the absence of conflict. It's conflict resolved into rhythm. Physicists call this dynamic equilibrium the state where opposing forces coexist without collapse. It's what keeps the cosmos stable yet alive, structured yet in motion. The universe thrives on this hidden balance, adjusting endlessly, never stopping, never still. When I think about that, I no longer see the universe as a machine. I see it as music, made solid harmony, made visible through the movement of everything that exists. Everything in the universe exists because opposites coexist. Matter and antimatter, attraction and expansion, heat and cold, each defines the other. Remove one and the system collapses. In the core of a star, gravity crushes inward while fusion pushes outward, and only their balance sustains the light. On cosmic scales, the pull of matter slows expansion, while dark energy accelerates it, the two locked in a silent equilibrium that defines the shape of time itself. The universe is not built from sameness. It survives through opposition, held in perfect tension. You can find this duality in everything. Day and night, life and decay, creation and collapse, each necessary, each incomplete alone. The roundness of the universe is their truce, a shape where opposites meet and coexist without destroying one another. Sometimes I think that's the secret of existence. Not victory, but balance. The universe doesn't choose sides. It turns endlessly between them. Energy never disappears. It only changes form, flowing endlessly through the curves of the cosmos. Gravity converts motion into heat, stars transform mass into light, and black holes return radiation to space as they evaporate. Even at its most violent, the universe keeps its accounting perfect. Einstein's equation E mc2 is not just a formula, it's a promise that matter and energy are two faces of the same circle. Every burst, every collapse, every flicker of light is part of one continuous exchange, endlessly curving back upon itself. In that symmetry, nothing is wasted. The universe simply rearranges its energy into new forms of roundness. From supernovae scattering elements to planets glowing with stored heat, every process pays its debt to balance. Energy flows, cools, condenses and reignites, never linear, always cyclical. Even death in the cosmos feeds creation somewhere else. When I think about that, I see the universe as a closed circuit of transformation, a vast spiral of conversions, all obeying the same quiet rule. That power, like gravity, moves in curves. Inside a star, matter is consumed by brilliance. Hydrogen fuses into helium, releasing light that has been trapped for millions of years. The transformation is astonishing, solid mass turned into pure energy, stone into flame. Every beam of sunlight that reaches Earth began as particles surrendering themselves to fusion, losing form to become illumination. This process powers galaxies, warms worlds, and writes the rhythm of life itself. When matter becomes light, it doesn't die. It transcends solidity, trading weight for motion, permanence for reach. Even beyond stars, this exchange continues. In particle collisions, in radioactive decay, in the quiet radiation of dying black holes, the boundary between matter and light is constantly crossed. What was once substance becomes wave, what was once confined becomes free. Sometimes I think the story of the universe is simply this: matter learning to shine. From the first stars to the last photon, it's all one continuous act of becoming light. Every photon begins its life deep inside a star, a flash of energy born from the crushing heat of fusion. It may take millions of years to escape scattering through layers of plasma bouncing from atom to atom. When it finally breaks free, it travels straight and patient, crossing the silent vacuum for billions of years, without slowing down, without growing old. Light does not experience time. To a photon, emission and arrival are the same instant. It carries no memory of the journey, only the message of where it came from. Each ray is a story written by matter and read by space. Some photons end their paths in our eyes, others vanish into dust, and countless more continue into eternity, illuminating worlds that don't yet exist. Every particle of light connects 2 points in time, the moment it left and the moment it's seen. To follow a beam is to travel backward, to glimpse the past still unfolding. When I look at starlight, I realize it's not the universe that moves, it's the light that carries time to us, one curved path at a time. Light does more than reveal the universe, it builds it. Radiation from the first stars sculpted clouds of hydrogen into structure, ionizing and pushing them apart. The glow from galaxies heated interstellar space, guiding how matter gathered and cooled. Even now, photons from quasars and cosmic rays shape the chemistry of worlds, altering atmospheres and sparking reactions that lead to life. Light is not a byproduct of creation. It is a force of creation itself, defining where gravity can build and where it must yield. Every form we see is drawn by light's influence, carved by illumination as much as by mass. Astronomers call this radiation pressure, but the term feels too small for what it does. Light sculpts nebulae into cathedrals of color, drives winds from stars, and sweeps dust into rings. Across the eons, it has written the universe into visibility, turning darkness into design. When I think about that, I realize light isn't the universe's reflection, it's its architect. The cosmos doesn't just shine. It takes shape in the glow it creates. Astronomers call this radiation pressure, but the term feels too small for what it does. Light sculpts nebulae into cathedrals of color, drives winds from stars, and sweeps dust into rings. Across the eons, it has written the universe into visibility, turning darkness into design. When I think about that, I realize light isn't the universe's reflection. It's its architect. The cosmos doesn't just shine, it takes shape in the glow it creates. From comet tails streaming behind their icy cores to the delicate rings of exoplanets, light's pressure leaves its signature everywhere. It burns, it pushes, it paints. In its absence, form would collapse into darkness unseen and undefined. Sometimes I imagine light as both artist and tool, the universe's way of sculpting beauty from chaos, of showing us that even something weightless can shape everything that exists. Every act of illumination creates a shadow. Even in the vastness of space where light seems endless, darkness follows close behind. When starlight strikes a dust cloud, it carves a silhouette, a region of calm hidden from radiation's force. These shadows are not voids, but sanctuaries where gravity can work undisturbed, forming new stars from cooled gas. The very presence of shadow allows creation to continue. Without darkness to shield it, light would burn the universe bare. The cosmos thrives not on brightness alone, but on the balance between what shines and what hides. Astronomers call these protected regions Bok globules, small round pockets of shadow floating in glowing nebulae. Inside them, the next generation of stars is already forming. Each dark sphere is a promise waiting for the moment it will burst into light. When I think of that, I realize shadow isn't the enemy of light. It's its partner, the quiet half of illumination shaping the universe one hidden circle at a time. The universe was once dark. For nearly 400 million years after the Big Bang, no stars had yet formed, only cooling hydrogen drifting through endless night. Then gravity began its quiet work, gathering gas into dense knots that ignited the first fires. When those first stars flared to life, their light filled the cosmos, ending the darkness forever. Astronomers call this era cosmic dawn, the moment when the universe became visible for the first time. Every star since then is part of that same lineage of light descendants of the first sparks that broke the silence. Those ancient stars were massive and short-lived, burning blue-white and dying in titanic explosions. Their death seeded space with heavier elements, the raw material for planets, oceans and life. The light they unleash still travels across the void, whispering the story of beginnings. When I look at the night sky, I'm seeing echoes of that first dawn photons older than our world, still tracing the round horizon of the universe's awakening. When the first stars ignited, their light didn't travel freely. It met the fog of the early universe, thick clouds of neutral hydrogen that absorbed every photon. Around each newborn star, a bubble of clarity formed a spherical zone where light ionized the gas and carved space open. These were the first true circles of light, expanding slowly until they overlapped, transforming darkness into a transparent cosmos. It was the universe learning how to see itself for the first time. Each glowing sphere marked a frontier, a boundary between what was known and what was still waiting to be revealed. Astronomers call this moment rionization, the transition from opaque to luminous. It didn't happen all at once, but through countless overlapping halos, each one round like a star's promise. The geometry of illumination itself became cosmic, reshaping the fabric of everything that followed. When I picture it, I see billions of expanding circles colliding and merging, until light filled every corner of the universe, a slow, graceful blossoming that began it all. As the first stars and galaxies bloomed, their bubbles of light began to touch. Each ionized sphere merged with its neighbors, dissolving the last islands of darkness that separated them. What began as isolated halos grew into a continuous glow, the rionization of the universe. This overlapping dawn unfolded over hundreds of millions of years, not as an explosion, but as a quiet flowering of radiance across the cosmic sea. The boundaries between shadow and light blurred until there were none left. The universe had completed its first transformation from a hidden world to one that could finally be seen. In that ancient dawn, the geometry of light became universal. Round fronts of illumination expanded from every direction, connecting galaxies long before they would ever meet. Even now, the light that filled those first horizons still echoes in the background radiation that surrounds us. When I think of that moment, I imagine the cosmos awakening, countless circles of brightness touching, merging and becoming one endless horizon of light. The universe is not expanding into space, space itself is expanding. Every point drifts away from every other, not because it's moving through something, but because the fabric between them is stretching. The galaxies are like dots on a balloon being inflated. As the surface grows, each dot moves away, though none are at the center. This expansion isn't chaotic, it's perfectly geometric, the same in all directions, governed by the silent rhythm of general relativity. It's the most elegant kind of motion, a universe growing rounder with every passing second. From the smallest distances to the cosmic horizon, this curvature defines everything. The faster the universe expands, the smoother its shape becomes, flattening the wrinkles of its youth. Yet on every scale, expansion keeps the same symmetry, a spherical growth written into the structure of spacetime itself. When I think about that, I picture the universe as a living sphere, not static, but breathing its geometry, swelling outward in perfect balance. Gravity is not a force pulling objects through space, it's the shape of space itself. Einstein revealed that mass and energy curve spacetime, bending the paths that everything else must follow. A planet doesn't orbit because it's tugged by an invisible hand, but because it's moving through a curved landscape, tracing the straightest possible line in a distorted geometry. The more massive the object, the deeper the curvature it creates and the stronger the illusion of pull. In the universe, motion and shape are one to move is to follow the curve of reality itself. This curvature ripples with every event. When stars collapse, when galaxies drift, when waves of gravity spread from distant mergers. Space and time flex together, creating a living architecture where nothing stands still. Even light, though massless, must bow to this geometry, curving around stars and black holes on its endless journey. When I think of that, I realize the universe doesn't contain gravity. It is gravity woven into the very fabric of space-time's roundness. Every mass in the universe bends the space around it, but the bending itself carries weight. Gravity gives geometry substance, a kind of pressure that shapes everything from starlight to time itself. Near massive objects, seconds stretch, distances warp, and reality thickens under the burden of curvature. In that sense, space is not an empty stage, but a living field heavy with the influence of what it contains. The more matter gathers, the more space curves and the more time slows in its presence. We usually think of gravity as weight, but really it's geometry, remembering where mass has been. Around black holes, this effect becomes absolute. Space-time folds so deeply that not even light can escape. There the weight of geometry turns into horizon, the ultimate curve where motion, matter, and time all surrender. Yet the principle remains universal. Everything massive changes the shape of the cosmos just by existing. When I imagine that I realize every particle, every planet, even us, leaves a tiny dent in the structure of reality, the universe acknowledging our presence in its curve. To fall under gravity is to move through depth, not down. The pull we feel isn't a direction. It's a descent into curvature. Every planet, every star, every black hole creates a depression in space-time, a valley that objects slide into along invisible slopes. The stronger the mass, the steeper the descent. Yet unlike a real landscape, these valleys have no walls and no floor, only gradients of time growing slower as the curvature deepens. To move through gravity is to move through time itself, bending toward the center of slowed existence. Gravity doesn't pull us down, it pulls us in. Near a massive star, clocks tick slower. Near a black hole, they nearly stop. Gravity stretches the rhythm of the universe, bending duration just as it bends light. This is why astronomers call it a well not of force, but of time. The deeper you go, the more the universe itself seems to pause. When I think of that, I realize falling isn't motion at all, it's surrender. The deeper the gravity, the more completely matter gives itself to the curve of space and the patience of time. Time does not flow evenly. In the vast machinery of the cosmos, every clock ticks at its own pace. Far from massive objects, seconds glide freely. But near the weight of a planet or the heart of a star, time stretches slowed by gravity's deep curve. Around a black hole that stretching becomes infinite to an outside observer. Anything falling in seems to freeze forever on the edge. What we call now depends on where we stand in the universe's geometry. There is no universal time, only local rhythms, each one tuned by the shape of gravity. Astronomers have confirmed this countless times. Atomic clocks on satellites run slightly faster than those on Earth, their distance from our planet's mass freeing them from its subtle drag on time. Even our daily technology, GPS communication systems, deep space probes must correct for these shifts or drift into error. When I think of that, I realize we live in a world where time itself bends slow and fast all at once, flowing differently everywhere, yet together, composing the same cosmic heartbeat. Light always moves at the same speed, yet it can appear to slow. When it passes near a massive object, gravity stretches the space it travels through, lengthening its path. From our perspective, the beam lingers bent and delayed, caught in the geometry of space-time. Around stars and black holes, this delay becomes profound. Light circles, loops, and in the strongest fields may orbit indefinitely. It's not that the light weakens, it's that space itself grows longer beneath its feet. In a curved universe, even the fastest thing we know must learn patience. Astronomers measure these delays to map invisible mass galaxies magnified and distorted by the light bent around them. It's called gravitational lensing, nature's way of showing that nothing, not even illumination, escapes geometry. Every arc of brightness we see is a story of time stretched and space reshaped. When I imagine that, I realize light doesn't just reveal the universe, it feels it tracing every contour, every curve, every weight, written into the structure of reality. Gravity bends like the way glass bends vision. When a massive object, a galaxy or a cluster of galaxies, lies between us and something more distant, its gravity warps space-time enough to deflect the light behind it. To our eyes, the background object appears distorted, magnified, or split into arcs of brilliance. These are gravitational lenses, natural telescopes made of gravity itself. They allow us to see farther than any mirror or detector ever could, revealing galaxies that would otherwise remain invisible. In the universe's design, even distortion becomes a tool for sight. Through these lenses, astronomers have witnessed some of the most ancient structures in existence, galaxies born only a few 100 million years after the Big Bang. The light that bends through those invisible curves has travelled for over 13 billion years, stretched and delayed by the geometry of mass. Each lens tells two stories at once, one about what lies behind it, and one about the gravity that shapes its arc. When I look at those cosmic rings, I realize that gravity doesn't hide the universe. It helps us see it more clearly, one curved reflection at a time. Everywhere in the universe, light reflects not just from surfaces, but from space-time itself. A galaxy cluster can act as a mirror, bending light from beyond into looping arcs that circle its mass. These cosmic mirrors don't reflect images backward, but inward, folding distance into visibility. When we look at them, we see time reflected too, the same galaxy appearing multiple times, its light arriving along different curved paths. It's a mirror made not of glass, but of gravity, turning the fabric of the universe into its own lens. In the cosmos, reflection is not repetition, it's revelation. Astronomers have used these natural mirrors to peer farther than any telescope could reach, seeing galaxies as they were before the Milky Way even existed. Some of these reflections arrive centuries apart, one echo after another across the curve of space-time. Every image is a different version of the same event replayed through geometry. When I think of that, I realize the universe is not just expanding, it's reflecting itself endlessly. Each light path, another angle of the same grand design. Light can echo, though not through sound, but through time. When massive objects bend its path, a single flash from a distant galaxy can reach us along multiple routes, each one delayed by years or even centuries. We see the same explosion more than once, played back through the geometry of space-time. These are gravitational echoes, nature's way of letting us watch a single moment unfold again and again. To the universe, repetition is not mistake but structure, as light retraces its own story through curved space. In every echo, the past finds a new way to arrive. Astronomers have already seen this phenomenon. Lensed supernovae appearing multiple times, their replays predicted by Einstein's equations decades before they were ever observed. Each echo confirms the shape of the cosmos, proving that time itself can bend, that light can find more than one path home. When I think of that, I realize the universe keeps its memories not in matter, but in motion, in the endless echoes of light finding new ways to be seen. The universe remembers not in words or symbols, but in motion and light. Every event leaves a trace. A ripple of gravity, a photon racing through space, a shift in the cosmic web that will last for billions of years. The past never truly vanishes, it just travels farther away. Even now, the light from the first stars still moves through the void, carrying the record of what once was. To look deeper into space is to look further into memory. Each image we capture another page from a history still unfolding. The sky is not just scenery. It's an archive written in light. Nothing in the universe is forgotten, only delayed. Information persists in radiation, in gravitational waves, in the motion of galaxies. Every atom holds the fingerprint of its origin. Every photon, a story of where it's been. The cosmos keeps its memory alive through geometry itself, curving space so that the past can still be seen. When I think of that, I realize memory is not a human invention. It's the universe's way of refusing to let time slip away without leaving a mark. Every ripple of gravity, every pulse of radiation, every faint whisper of a decayed particle becomes a thread in the universe's fabric of memory. Space itself holds these threads not as frozen moments, but as distortions, ripples, and waves that never fully fade. When a black hole collides, it sends a vibration through space-time, and that echo moves outward forever. It's as if the cosmos records its experiences in its own body, each wave a reminder of something that once happened somewhere long ago. The universe doesn't just remember events, it remembers motion. Gravitational waves first detected in 2015 confirmed this truth. We can now listen to the fabric of space-time ringing with the memory of cosmic collisions, black holes spiraling into one another, neutron stars tearing themselves apart. These aren't metaphors. They're the literal tremors of creation still passing through us at the speed of light. When I think about that, I realize memory in the universe isn't silent. It hums endlessly, a background song of everything that ever moved. Existence itself is never still. Every movement, every collision, every heartbeat of a star sends ripples through space-time, faint vibrations that travel forever, carrying the imprint of their source. When two black holes collide, they shake the universe like a bell, and that ringing spreads outward across billions of light years. These are gravitational waves, distortions so subtle that they stretch and squeeze reality by less than the width of an atom, yet their reach is infinite. The universe doesn't echo with sound, it resonates with motion. In 2015, humanity first heard this cosmic music, the merging of two black holes more than 1 billion light years away. The detectors on Earth trembled as space-time itself passed through them, and for the first time we listened to gravity. Each new detection since then adds another note to this vast composition. Stars dying, galaxies merging, the cosmos singing to itself. When I imagine those ripples, I realize existence isn't defined by what stands still, but by what keeps moving endlessly, rhythmically, beautifully. Space-time sings not in air or vibration, but in curvature. Every collision, every orbit, every shift in gravity produces a note in this invisible symphony. When two neutron stars spiral together, their orbits tighten and the frequency of their waves rises like a crescendo. When they merge, the tone peaks, then fades into silence as the new black hole settles. Astronomers can now hear these events, translating the ripples of gravity into sound, deep resonant hums that carry the weight of dying stars. It's music without instruments, composed by motion itself. Each detection adds another harmony to the cosmic score. Some waves are sharp and brief, a single collision in eternity. Others are long and soft, spanning entire galaxies. Together they form a constant background hum, the music of space-time still vibrating from the earliest days of creation. When I think about that, I imagine the universe as a vast orchestra, each star and planet a player, each movement another note in the endless song of gravity and light. The most beautiful music in the universe cannot be heard. The waves of space-time pass through everything, through planets, through stars, even through us without sound or resistance. They carry no air to vibrate, no medium to stir, and yet their rhythm is perfect, steady, ancient. The silence between galaxies is filled with these invisible harmonies, rippling across the cosmos from every collision that ever was. If our ears could hear gravity, the night sky would roar with song. The silence of the universe isn't emptiness. It's the sound of perfection beyond hearing. When scientists convert these ripples into audible tones, What emerges is haunting. Low, steady notes rising into brief bursts of thunder, like drums struck across time. Every tone is the death cry of stars, the heartbeat of black holes, the memory of motion turned to music. When I think about that, I realize silence isn't absence. It's the universe's way of speaking in a language older than sound, the silent symphony of everything that has ever moved. If you could step outside time, you would see the universe performing not like an orchestra reading from a score, but as the score itself. Every law of physics is a note, every equation a rhythm, and the instruments are stars, galaxies, and atoms all playing their roles in perfect synchrony. There is no composer standing above it. The act of existing is the music. Space-time matter and energy improvise together, following rules that have never once broken in 14 billion years. The universe doesn't need an audience, it's both musician and melody. In this cosmic performance, harmony emerges not from intention but from inevitability. Gravity keeps the beat, light carries the melody, motion and curvature provide the tempo. Even chaos, explosions, collisions, decay becomes part of the rhythm. Never truly random, only complex. When I think about that, I realize the universe is not silent, not still, not waiting to be understood. It's performing right now, endlessly, elegantly, and perfectly in tune with itself. Every performance follows rules, and the universe is no different. Its score is written in constants, the speed of light, the strength of gravity, the charge of the electron. Change any one of them even slightly, and the melody collapses. At a higher speed of light, atoms couldn't bind. A weaker gravity and stars would never ignite. These numbers aren't arbitrary. They're the tempo of existence itself, steady and exact. Across the cosmos, every note from starlight to quantum spin plays in harmony, because the constants never miss a beat. The universe is not chaos tuned into order. It is order expressed through motion. Physicists call this fine-tuning, but it feels more like inevitability. The constants don't adapt to the universe. The universe exists because they do. Everything from the shape of galaxies to the warmth of sunlight depends on their precision. They are the invisible metronomes that keep time for reality's endless song. When I think of that, I realize we live inside a perfect score, one that never began, never ends, and never misses a note. Everywhere we look, the same constants hold. The speed of light, 299 million meters per second. The gravitational constant, the quiet thread linking mass to motion. The Planck constant, the smallest pulse of action in existence. Together they form the scaffolding of creation, a set of unchanging values that shape every atom, every star, every law. They are the boundaries within which existence can unfold the invisible frame, keeping the universe stable as it dances through time. Without them, there would be no pattern, no form, no rhythm for the cosmos to play within. The precision of these constants is astonishing. If gravity was slightly weaker, stars could never fuse hydrogen. If it were stronger, they'd collapse too soon. If the charge of the electron shifted by the tiniest fraction, chemistry itself would fail. These numbers are not just measurements. They're the instructions written into the universe's design. When I think of that, I see creation not as an accident, but as balance, so exact that it feels inevitable, the constants themselves composing the universe into being. Reality is balanced on the edge of perfection. The constants of nature align with such precision that even the smallest deviation would erase the possibility of stars, planets, or life. The ratio of the electron's mass to the protons, the fine structure constant that governs how light interacts with matter, each one tuned to dozens of decimal places. It's a harmony so exact that physicists compare it to firing an arrow across the universe and hitting a target the width of an atom. The universe doesn't just exist, it calculates itself with flawless precision. This delicate balance raises a profound truth. Randomness alone cannot explain order so complete. Yet it isn't design in the human sense, it's the inevitability of mathematics shaping matter. The constants are not chosen. They emerge self-consistent like the rules of a melody that could not be played any other way. When I think of that, I see reality as something deliberate, not planned but precise, a structure so exact that even chaos must obey its rhythm. Beneath every galaxy, every atom, every flash of light, there lies a code not written in symbols but in relationships. Numbers describe how reality behaves, how fast it moves, how much it bends, how long it lasts. From Einstein's field equations to Schrödinger's wave functions, the universe expresses itself through mathematics as if existence were a proof unfolding across space-time. These equations don't just describe the cosmos. They are the cosmos, the logic that allows energy to take form and symmetry to find balance. Matter is what happens when mathematics becomes real. Physicists often say the universe is not merely governed by math, it is math. Every constant, every pattern, every orbit and spin follows rules that require no observer, no correction, no rehearsal. The cosmos doesn't guess, it computes. When I think about that, I see numbers not as inventions of thought, but as discoveries, glimpses into the eternal architecture beneath all motion. The language of reality is already written. We are just learning to read it. At every scale, the universe expresses itself through geometry. Atoms form spheres, planets trace ellipses, galaxies curl into spirals. Even time, when shaped by gravity, bends into curves. Geometry is the universe thinking in form the way mathematics becomes visible. The path of a photon around a star, the arc of a comet, the swirl of a storm all obey the same geometric rhythm written in the equations of relativity and motion. The cosmos doesn't just occupy space, it creates space through the geometry of its existence. Every shape is a solution, the universe solving itself through curvature. Einstein showed that matter tells space how to curve and space tells matter how to move. This dialogue between geometry and motion defines everything from falling apples to collapsing stars. The roundness of worlds, the orbits of moons, even the arcs of galaxies are the same story told in different scales. When I think of that, I realize geometry isn't decoration, it's destiny. The universe has always known how to draw itself. Everything we know takes shape. From the crystal lattice of a snowflake to the orbit of a planet, reality reveals its logic through form. These shapes aren't arbitrary. They are the visible consequences of hidden laws. A snowflake's symmetry arises from the molecular angles of water. A planet's roundness from gravity-seeking equilibrium. Even galaxies, those vast islands of light, spiral because angular momentum must be conserved. Every structure, no matter how chaotic it seems, is geometry wearing the mask of motion. The universe doesn't design, it settles, and from that settling beauty appears. At its heart, reality is a sculptor working with energy and time. Pressure, rotation, and attraction are its tools. The same principles that shape a droplet also shape a star. The cosmos is recursive, repeating its patterns in endless scales, from the curl of a wave to the curve of space-time itself. When I think of that, I realize there are no true straight lines in nature. Only curves, spirals, and arcs, the signatures of a universe that cannot help but move beautifully. Beneath every visible structure lies an invisible architecture, forces and equations arranging matter into harmony. The pillars of this architecture are simple: gravity, pressure, rotation, and radiation. Together they build everything from the smallest droplet to the largest galaxy cluster. Each law acts like an architect's hand guiding matter toward equilibrium. Stars round themselves to minimize tension. Planets flatten at their poles to balance rotation. Even galaxies spread their arms in spirals, tracing the natural flow of angular momentum. Form isn't random. It's what happens when the laws of physics agree on beauty. In this grand construction, energy is both the blueprint and the builder. It stretches, contracts, and redistributes, turning chaos into design. Over billions of years, the architecture refines itself. Stars give birth to elements. Elements build worlds, and worlds nurture life. All of it born from the same geometry, the same balance written into the foundation of reality. When I think about that, I see no separation between structure and story. The universe doesn't build things, It builds reasons for things to exist. If you could strip the cosmos of all matter and light, what would remain is its blueprint, a web of rules, constants, and relationships. Space would still curve, time would still flow, and geometry would still exist, waiting for energy to give it form. This invisible design isn't a plan drawn in advance, but a framework that ensures consistency. Every particle knows how to move because space-time tells it where to go. Every atom knows how to bond because the forces governing it have never once changed. The blueprint of the universe isn't drawn, it's implied by the laws that never break. This hidden scaffolding connects everything that exists. It explains why galaxies cluster, why planets orbit, why atoms remain stable. It's the unspoken order beneath creation, not designed by intent but sustained by necessity. The laws of physics don't control the universe. They are the universe expressed in mathematical certainty. When I think of that, I realize reality doesn't need an architect. The blueprint writes itself every instant, in every motion, in every curve that space allows. At first glance, the universe seems chaotic, stars, exploding galaxies, colliding matter scattered through endless space. But beneath that turbulence lies order so precise it borders on perfection. Every explosion follows conservation laws. Every orbit obeys symmetry. Even randomness itself conforms to probability, the quiet rhythm behind what we call chance. The hidden order of the cosmos isn't a pattern we impose, it's the foundation on which existence stands. Without it, motion would unravel and time would lose its direction. Chaos in the universe is only the surface of a deeper symmetry. This order reveals itself in everything, in the repeating spirals of storms and galaxies, in the fractal growth of coral and clouds, in the predictable hum of subatomic fields. It's as if the same blueprint is stamped across every scale, written in the language of recurrence. We mistake it for coincidence, but it is coherence. The cosmos maintaining balance through infinite diversity. When I think of that, I realize disorder is not the opposite of order. It's how the universe keeps the pattern alive. Chaos is not the enemy of order, it's its birthplace. In the turbulence of clouds, in the spin of galaxies, in the flicker of plasma around stars, patterns emerge not despite disorder but because of it. Tiny fluctuations amplify, creating spirals, filaments, and flows that repeat across scales. Mathematicians call this chaotic determinism, systems that appear random but follow rules so complex they hide their order from view. The universe in this sense is not a machine but a storm, precise, unpredictable, and endlessly creative. From chaos structure arises, from structure motion endures. You can see this pattern in everything. The branching of rivers and lightning, the growth of coral reefs, the turbulence of galaxies. Each looks wild, yet all share the same fractal geometry, a rhythm of repetition nested within itself. Chaos gives nature freedom but never lawlessness. It ensures no two stars, storms, or lives are ever identical, while still obeying the same principles beneath. When I think of that, I realize chaos isn't the opposite of control. It's the universe exploring every way order can exist. Look closely at the universe and you'll see repetition disguised as diversity. Galaxies form clusters that resemble branching trees. River deltas mirror lightning strikes. Clouds swirl like galaxies billions of times their size. These are fractals, patterns that repeat at different scales, each echoing the structure of the whole. The universe builds itself this way through self-similarity, where the small contains the shape of the vast. From atomic orbits to galactic arms, the same geometry reappears. Curves, spirals, filaments, as if the cosmos keeps redrawing its own reflection. Everywhere we look, the universe repeats one truth. Pattern is scale made visible. Physicists call this scale invariance, the idea that the laws of nature don't change with size. The same mathematics that describes a whirlpool can describe a hurricane or a spiral nebula. Nature never needs new rules, it just reuses the old ones beautifully. This is why galaxies, storms, and even blood vessels share the same logic of flow. When I think of that, I see the universe not as infinite variety, but as infinite iteration. one grand design repeating itself in every possible form. The deeper we look into the universe, the more it seems to look back. Every pattern, every curve, every repetition feels like a reflection of something greater, as though the cosmos is mirroring itself across endless scales. Galaxies form spirals that echo the shapes of hurricanes and seashells. The filaments of the cosmic web resemble the neurons in a brain. It's as if the universe, in creating structure, also created self-similarity, an infinite hall of mirrors where each layer contains the ghost of the last. We are not outside that reflection. We are one of its returning images. Some physicists call this cosmic self-similarity. Others see it as coincidence. But the more we study, the clearer it becomes. The same mathematical patterns appear from the quantum scale to the galactic. It's as if the universe cannot help but repeat itself, because repetition is stability, and stability allows existence to endure. When I think of that, I wonder if consciousness itself is another mirror, the universe's way of seeing its own reflection and calling it awareness. Somewhere between the birth of matter and the rise of stars, the universe began to look back at itself. Through life, and eventually through consciousness, the cosmos gained eyes to witness its own unfolding. Every neuron firing in a human brain is an echo of ancient starlight atoms forged in stellar cores, now exchanging signals across electric storms of thought. We are not separate from the universe's machinery. We are its continuation matter that has learned to observe. When the universe evolved minds, it did not create something new. It simply remembered that it exists. Consciousness is the latest symmetry awareness mirrored through complexity. The same physical laws that govern the orbit of planets now govern the patterns of our thoughts. And when we gaze into the night sky, we complete the circuit, the cosmos contemplating itself through us. When I think of that, I realize we are not small. We are vast extensions of a universe that became aware for a brief moment of its own beauty. Every time we lift our eyes to the sky, the universe completes a loop observer and observed becoming one. The light we see left its source billions of years ago, long before Earth formed, long before thought existed to receive it. Yet here it arrives, falling upon retinas made of the same atoms that once burned inside those distant stars. When we look at the cosmos, we are watching the past touch its own future. It's not a gaze across space, but across time. The universe doesn't just shine into us, it sees itself through us. Telescopes extend that vision, turning humanity into the universe's longest mirror. With each discovery, from distant galaxies to the whisper of background radiation, we return a piece of the cosmos to its own awareness. It's a quiet dialogue between light and consciousness, a conversation billions of years in the making. When I think of that, I realize that every observation is a reunion, the universe remembering itself in the gaze of its children. If consciousness is the universe looking inward, then awareness is its most mysterious creation. Somehow, from the blind collisions of atoms' thought emerged patterns of matter complex enough to ask where they came from. Neurons built from elements born in stars began to dream, to imagine, to measure their own existence. It's as if the universe arranged itself into a shape that could feel its own symmetry. The laws that govern galaxies also govern the spark behind every human question. The cosmos, through us, has learned to wonder about itself. Perhaps this is not coincidence, but continuation. Complexity is what the universe does. It folds curves and organizes from particles to planets, from life to mind. Consciousness may be its highest curve, a new form of geometry drawn not in space but in thought. When I think of that, I see no separation between mind and matter. Awareness is not outside the cosmos. It is the cosmos waking up for a moment to realize what it has become. If the universe can give rise to consciousness, then in some sense mind is one of its natural states. The neural networks in our brains, the electrical storms of thought, follow the same physics as the plasma currents of stars. Both process energy, balance chaos with order, and evolve toward complexity. In that way, the mind is not separate from the cosmos. It's a smaller version of its pattern, a reflection of universal logic on a microscopic scale. Perhaps what we call mind is the cosmos thinking locally, a fragment of infinity becoming aware of itself. The more we study the brain, the more it resembles the universe that made it. Networks of connection, constant motion harmony born from chaos. Information flows through neurons as gravity flows through galaxies, always seeking balance, never still. Awareness then is not a miracle, but a mirror. When I think of that, I wonder if thought itself is the universe's way of folding back matter, reaching a point so intricate that it begins to know. When scientists map the large-scale structure of the universe, they find something uncanny. A web of galaxies connected by thin filaments of dark matter nodes glowing with clusters of stars. And when neuroscientists map the human brain, they find a pattern strikingly similar: neurons linked by synapses clustered into networks pulsing with electrical fire. Two systems separated by unimaginable scales yet united by design. Both seek efficiency, both balance connection with space. It's as though the same principle, the drive to organize complexity, shapes galaxies and thoughts alike. We are built from the same architecture that holds the stars together. In both the brain and the cosmos, information flows along these networks. In one, signals of electricity, in the other, streams of light and gravity. Each node carries meaning, a neuron forming memory, a galaxy birthing new suns. The universe and the mind mirror one another, not because they share material, but because they share mathematics. The geometry of connection. When I think of that, I realize that consciousness may not be an exception in nature. It may be its inevitable pattern, arising wherever the universe learns how to connect. From the smallest atom to the largest cluster of galaxies, everything returns to the same truth. The universe is round because roundness is the shape of balance. Matter curves, time loops, gravity bends, and light follows the arc. Even thought moves in circles, revisiting old questions in new forms. Existence is not a straight line toward an ending, but a curve, an eternal motion without edge, without center, without loss. The circle is how the universe remembers itself, endlessly repeating its own perfection. In every orbit, in every pulse of light, in every act of awareness, the roundness continues. We began by asking why everything is round. But maybe the better question is, could it have been any other way? The laws that shape stars also shape us. The balance that holds planets steady is the same that steadies our thoughts. In this symmetry, we find meaning not imposed but discovered, drawn, in the same quiet geometry that holds the cosmos together. The universe turns, and so do we. One endless motion, one shared horizon, one perfect circle, forever closing, forever beginning.